For more than 4,000 years, they've stood in silence, immovable, flawless, almost alive. The Great Pyramids of Egypt, built with a precision no civilization since has matched. A base levelled within 2 centimetres. A line to true north within a margin smaller than a human heartbeat. But the deeper scientists look, the stranger it gets. Geometry that predicts pi and the golden ratio. Blocks hauled from quarries hundreds of kilometres away. Passages pointing to stars we hadn't even named yet. None of it should be possible, and yet every measurement proves it is. Welcome to the 101 Archive. Tonight, we'll uncover 101 disturbing reasons why the pyramids still terrify scientists. Before we begin, tell us in the comments where you're watching from. You stand before the Great Pyramid and realize that even silence here feels engineered. The wind dulls at the base, the air thickens near the stone, as though geometry itself has learned to trap sound. Centuries of excavation, surveying and measurement were meant to quiet the questions. Instead, every new number has made the mystery louder. When 19th century engineers first mapped this monument, they expected roughness, a Bronze Age approximation of perfection. What they found was a base so level that across 230 meters, the variation never exceeded the thickness of a thumb. Modern laser instruments would record the same, 2 centimeters of deviation total. The pyramid faces true north within 3 arc minutes, a precision that would challenge professional builders today, even with satellite guidance. No document from the 4th dynasty explains how such accuracy was achieved. That is where curiosity began to turn to discomfort. Because when you compare this monument to any other structure on Earth, ancient or modern, the pattern repeats. Everything fits within an order of magnitude too advanced for its supposed age. Archaeologists can name the workers, the quarries, the pharaoh, Khufu, but not the principle that aligned limestone to the rotation of the planet itself. Historians can measure, but they cannot replicate. Inside the cool darkness of the descending corridor, the contradiction deepens. The blocks, some weighing over 15 tons, interlock so tightly that you could not slide a sheet of paper between them. No mortar fills the joints, only gravity, pressure, and human intention. The passage angles downward at precisely 26 degrees, 31 minutes, meeting the ascending shaft at a point calculated to millimetric tolerance. These are measurements verifiable by any engineer. What they imply that such control was possible in 2560 BCE remains open to debate. When surveyor Flinders Petrie published his exhaustive report in 1880, he recorded his own disbelief. He called it a structure built as though by instruments, not by hands. Later analysts would confirm that if you divide the pyramid's perimeter by twice its height, you obtain 3.1416 p, accurate to 4 decimal places. If coincidence, it is a remarkable one. If intention, it means that whoever planned these stones understood relationships between circle and square centuries before Greece. Either conclusion unsettles scholars. Chance on that scale is improbable, knowledge on that scale inexplicable. The base itself seems to speak another language, one of planetary ratios. Multiply its height by 10 million and you arrive, almost exactly, at the Earth's polar radius. Shrink the Earth's circumference 43,200 times, and you trace the pyramid's perimeter. Mathematicians insist these numbers may simply emerge when one seeks enough patterns. Others counter that randomness seldom aligns with celestial mechanics so neatly. The debate endures, oscillating between probability and awe. You move further in, the temperature falling with each step. The stones sweat faintly. Their surfaces, once sheathed in white Tura limestone, would have glowed in the sun like polished quartz. Ancient writers described the pyramid not as grey but as dazzling, visible from miles across the desert, a beacon more than a tomb. If light could have a geometry, this was its prism. Yet the more scientists examine it, the less it resembles a sepulchre. No inscriptions inside name the dead, no sarcophagus lid, no grave goods, no hieroglyphs of mourning, only an empty granite coffer carved from a single block of Aswan granite, transported 900 kilometers upstream. How such a weight crossed sand and river remains one of archaeology's practical riddles. Theories multiply: wooden sledges on wet clay, rolling logs, rope systems, long ramps whose evidence has eroded. In 2018, excavations at Hatnub revealed a ramp angled between stairways, perhaps proof of the method. But the calculations suggest something else. The friction load alone would have demanded a power output equal to a small modern engine. And that is the border where evidence meets imagination. Some engineers suspect the ancient masons possessed an empirical mastery of leverage, now forgotten. Others propose techniques involving water flotation or counterweights buried beneath the plateau. Every hypothesis still breaks against the same wall of numbers. The project required placing one block every 2 minutes for 2 decades without significant error. Archaeology acknowledges the logistics. Physics questions the feasibility. Among Egyptologists, there is a phrase, half serious, half weary. The pyramid builds itself. They use it to mean that the data no longer bend to tidy narratives. Each new scan, laser, sonar, or muon reveals internal precision, not primitive improvisation. Even the supposed mistakes, tiny asymmetries in the casing stones, appear deliberate, balancing thermal expansion, as if the builders anticipated heat stress 4 millennia before industrial materials science. And that is perhaps why scientists admit to unease. The pyramid is measurable, datable, tangible, yet intellectually evasive. It yields facts, then rearranges them into paradox. Consider the orientation once more. To face true north so closely, a builder would need to measure the Earth's rotation and tilt, phenomena officially quantified only in the Hellenistic era. Some researchers propose that the Egyptians tracked circumpolar stars crossing the meridian at night, aligning by observation. Others argue such accuracy would still require correcting for atmospheric refraction and precession. Either the ancient astronomers possessed that knowledge intuitively, or they achieved an impossible accident 10 million times over. Neither answer satisfies the rational mind. The discomfort is not mystical, it is methodological. Science is built on repeatability, but here repetition fails. You can measure, you can model, yet you cannot do it again with Bronze Age tools. Every replica falls short, every simulation adds modern conveniences unacknowledged. The monument resists being reduced. Standing inside the Grand Gallery, you can feel that resistance physically. The ceiling rises like the interior of a massive instrument, 7 tiers of corbelled stone drawing sound upward. Engineers have noted its acoustic resonance, near 440 Hz. The frequency of concert A, whether intentional or incidental, that tone vibrates through the stone and your chest alike, as if the architecture itself were humming the question you came to ask. Historians prefer humility. They remind us that intelligence does not belong to the present alone. Ancient Egypt achieved wonders in medicine, mathematics, and engineering. To underestimate them is arrogance. But even those scholars confess a private astonishment, because after 2 centuries of study, the Great Pyramid still refuses to behave like an artifact of its time. When the 1880 surveyors packed their instruments and left Giza, they believed they had mapped a monument. Instead, they had charted a mirror, one that reflects back the limits of what we think ancient humanity could know. The data are real. The implications remain a debate carried in whispers at conferences and in the margins of papers. And if the foundation of this enigma is so exact, what of the rest? The angles, the stones above, the hidden chambers, modern sensors, now glimpse but cannot reach. You'll see that the deeper the measurements go, the less they explain. Precision becomes paradox, and the closer the numbers get to perfect, the more impossible they seem. because in the next step of this journey, you'll follow the scientists who tried to measure perfection and found themselves staring into something colder than stone, mathematics that refuses to belong to its century. You have seen the outer perfection. Now you step into the language of numbers, the silent mathematics chiseled into limestone. Every stone, every angle, seems to carry an equation no one remembers writing. Surveyors begin with what can be verified. Each face of the Great Pyramid slants at precisely 51 degrees, 50 minutes. The four angles are almost identical, a variance smaller than any mechanical level could easily detect. The whole base is so square that the difference between its longest and shortest sides is less than 5 centimeters. These are measurements confirmed by satellite and laser. They are not legend, they are data, yet the data refuse to sit quietly. When the first engineers divided the perimeter of the base by twice its height, the result was 3.116 pi, a constant of circles somehow locked inside a structure of squares. Mathematicians call it coincidence, geometry's natural echo. But coincidence rarely repeats itself across four faces carved in the 26th century BCE. Others whisper that the builders must have discovered pi empirically, long before the Greeks named it. Either answer leaves the same taste, improbable order. As you trace the slope upward, geometry folds into astronomy. The narrow shafts rising from the king's and queen's chambers point not to the desert, but to the sky, to Al-Nitak in Orion, and to Sirius. Modern measurements confirm the alignment within less than a single degree. If the orientation was deliberate, then ancient eyes had tracked stars with an accuracy rivaling modern theodolites. Egyptologists explain that by watching a pair of circumpolar stars cross the meridian, builders could find true north. It works on paper, but correcting for refraction, for the slow wobble of Earth's axis called precession, would demand calculations known only thousands of years later. No one can prove they did, no one can prove they didn't. Even the cardinal directions themselves are perfect. Each face of the pyramid is oriented almost exactly to north, south, east and west. The deviation less than 3 arc minutes is finer than what many 20th century observatories achieved before computers. How did Bronze Age surveyors achieve what once required gyroscopes and compasses? Some suggest shadow tracking, others the reflection of the North Star in bowls of water. Both methods work roughly, neither explains the precision. Then there is the proportion that bridges Earth and heaven. The pyramid's height multiplied by 10 million equals, within a whisper, the planet's polar radius. Its base perimeter, scaled up 43,200 times, matches Earth's circumference. No one has found papyri claiming the Egyptians measured the world, yet the numbers sit there, etched in stone, patient as gravity. For mainstream archaeology, it is geometry's accident, a byproduct of ratios pleasing to the eye. For a smaller circle of researchers, it hints that the builders possessed observational knowledge we have lost, perhaps derived from centuries of watching the sun and the flood of the Nile. Between those positions stretches a quiet tension that no peer review can dissolve. The pyramid also encodes fear, the golden ratio, hiding in the slope of its sides. The relationship between half the base and the height approaches 1.618. The harmony between psi and fear inside a single monument tempts numerologists, but even conservative scholars admit the coincidence is curious. How many coincidences does it take before pattern becomes intention? Inside, the silence deepens. Instruments measure not noise, but resonance. Standing waves near 440 Hz, pulsing through granite corridors. The tone is close to concert A, though the ancients had no concept of Hertz. Physicists record it as natural consequence of dimensions. Acousticians wonder if it was tuned by design. When sound or chanting fills the king's chamber, pressure nodes vibrate precisely where the walls meet. What began as a tomb behaves like an instrument. Every measurement that should reassure instead unsettles. The more exact the numbers, the further they drift from plausibility. Engineers build models with copper tools, soft stone, and ramps. They reproduce fragments but never the whole. Their miniatures wobble, their joints misalign, their surfaces diverge by degrees. The original does not. It remains indifferent to replication, like a problem that knows its own answer. Some researchers note another pattern: the latitude of the Great Pyramid, 29.9792 kilometers. The match is perfect only in the metric system, invented thousands of years later, almost certainly a coincidence. But the resemblance feeds the superstition that physics itself hides in the layout. Scientists dismiss the claim, yet quietly acknowledge that the coincidence is at least poetic, a reminder of how human curiosity bends toward meaning even in randomness. Archaeology's comfort lies in context, and here context erodes. No papyrus describes the calculations. No workshop tools explain the tolerances. The builders left a monument without a manual. When modern teams scanned it with muon detectors, the voids they discovered did not clarify the geometry, they multiplied it. One cavity 30 meters long floats above the Grand Gallery like a pocket of air trapped inside an equation. It should not exist, and yet it does. The closer you look, the more the lines blur between architecture and astronomy, mathematics and myth. Did the ancient engineers simply strive for symmetry, or were they mapping the heavens in stone? Did their gods demand perfection, or was perfection itself the god they served? The questions are older than translation. A physicist once remarked that studying the pyramid feels like doing reverse engineering on time. You dismantle precision back into uncertainty. You strip logic until you are left with wonder. That, perhaps, is why the monument still unnerves its observers. It is both measurable and unknowable, a paradox built to scale. Step outside again, and the desert light stings your eyes. The pyramid's four faces catch the sun like blades, each angle throwing back a reflection so exact that even satellites use it for calibration. You begin to see why scientists describe it not as ruin, but as reference, a standard against which human accuracy is still compared. The irony is cruel. The most advanced structure of the ancient world is also the one least understood. And so the measurements keep multiplying. Pi, phi, alignments, ratios, each one dragging the question further from the certainty it promised to bring. The numbers do not lie, but they refuse to explain themselves. Somewhere between calculation and myth lies the truth, buried like another chamber, waiting for a light we have not yet invented. Because beyond the mathematics, there are the materials, stones cut from quarries 900 kilometers away, each heavier than reason allows. To measure is one thing, to move is another, and that, as you'll soon discover, is where the next impossibility begins, the question of how mere hands shaped the unshakable. The desert is quiet until you imagine the sound it once carried, the crack of granite, the rhythm of hammers, the breath of thousands hauling weight beyond measure. Nothing remains of the noise, only the stones themselves, and they still look too heavy to have ever moved. Each block in the Great Pyramid averages 2 tons. Some in the King's Chamber weigh closer to 80. Geologists can still trace their origin to Aswan, 900 kilometers south, where rose-red granite glitters under the same sun. In the quarries, unfinished pillars lie abandoned mid-cut, their surfaces etched with parallel striations, the signature of copper saws driven by sand and patience. The grooves are real, the copper fragments still visible beneath the desert varnish, proof that stone did yield to simple metal and grit. Yet the evidence of effort deepens, rather than closes the mystery. Experimental archaeology shows that a team of men with copper saws can slice a block in days, but not with the smooth curvature preserved on ancient cores. Under magnification, those striations twist into a spiral, as if the drill bit had rotated continuously under steady pressure. Modern diamond tools produce the same pattern. How Bronze Age workers maintained that precision with hand-turned drills remains unexplained. Engineers can reproduce the cuts only with machines delivering uniform torque. Muscles alone leave wobble marks. Some scholars call it the problem of consistency. Human labour is irregular, yet these cuts are mechanical in rhythm. The mainstream explanation invokes abrasive slurry, quartz sand trapped between copper and granite, acting as a natural blade. It works slowly if you accept months for each section. But the scale of Giza demands millions of such sections. To finish in 2 decades, the rate of stone movement must have been 1 block every few minutes for 20 years. A calculation printed in engineering journals, not conspiracy tracts. Numbers that should reassure instead unnerve. Around Aswan, archaeologists have mapped ancient ramps, still carved into the quarry walls. Their slopes gentle enough for sledges, greased with water or milk fat. Reliefs from other sites show teams hauling statues on wooden runners, while men pour liquid ahead to reduce friction. The method is plausible and tested. A Dutch team replicated it in 2014, confirming that wet sand halves the pulling force. The experiment works for 10-ton statues on short distances. Scaling it to 80-ton beams across desert and river still stretches physics thin. To bridge that gap, hypotheses multiply. One proposes barges during the Nile's flood, floating stone northward to a harbour near the plateau. The river's seasonal rise could have eased transport, turning geography into ally. Papyri from the Diary of Mira, the foreman whose writing survived in fragments, described ferrying limestone for the pyramid's casing. His notes prove a system existed. They do not explain how the granite ceiling of the king's chamber arrived intact. Those ceiling blocks are the most troubling. 7 slabs, each longer than a bus, and weighing nearly 70 tons, rest 30 meters above the floor. They are not decorative. They bear the weight of the pyramid's upper mass. To raise them required staging that modern cranes barely equal. No ramp remnants point clearly to that level. Some engineers suggest internal corridors of rising switchbacks, spiral ramps hidden within the pyramid's body. Scans have yet to confirm them. Others imagine counterweights, sand-filled shafts acting like pistons. None of these models survives full simulation without invoking more material than the builders could supply. That is where the debate turns from mechanics to possibility. Materials scientists analyzing microscopic residues on certain drill cores have detected traces of an unknown bronze alloy, harder than standard copper. The find is fragmentary, not enough to rewrite metallurgy, but enough to provoke argument. Could artisans have mixed arsenic or tin in secret ratios that hardened their tools? The chemistry allows it. The archaeological proof is elusive. For some researchers, the scale of the work implies an empirical knowledge of leverage lost to time, a physics learned by trial, not formula. The ancient Egyptians did not need equations. They had experience, generations of observation, an intuitive geometry honed on every obelisk they raised. For others, even that explanation falters. The energy expenditure alone, 5 million tons of stone lifted and set, demands logistics bordering on the impossible for a Bronze Age population. What end justified it? Official inscriptions call the pyramid Akut Khufu, horizon of Khufu, a gateway to eternity. Yet the building behaves less like a tomb than a machine. Shafts, chambers, vents, relieving spaces, all arranged as if to balance forces rather than honour death. Some acousticians note how granite amplifies vibration. Some physicists point out the piezoelectric potential of quartz in the stone. These are observations, not conclusions, but they feed the idea that energy, light, sound, or pressure might once have been part of its design. Standing inside the king's chamber, you can sense that speculation rising with the heat. When a single tone hums between the walls, the air thickens. Instruments register harmonic nodes exactly where the ceiling blocks join, as though the mass itself were tuned. Scientists call it coincidence of dimension. Mystics call it intention. Between them hangs a sound, older than argument. The stones tell a second story through their precision of fit. In the ascending passage, the gap between blocks averages less than a millimeter. No mortar fills it. The seal is friction and gravity alone. Even today's machinists would struggle to achieve such tolerance across so vast a surface. Engineers have measured the same phenomenon in the pyramids of Sneferu at Dashur, suggesting a continuum of experiment leading up to perfection at Giza. Each project learned, adjusted, improved. The pattern hints at generations of disciplined innovation rather than miracle, but innovation of an order still difficult to imitate. Among archaeologists, the debate has softened from disbelief to awe. They no longer doubt human authorship, they doubt only the limits of human patience. To carve granite with copper, to haul it by hand, to align it by stars, all within a mortal lifetime, defies not physics, but imagination. That defiance, more than any lost technology, is what terrifies scientists most. The reminder that civilization can exceed its own record. At sunset, when the last light burns along the edges of the blocks, the granite glows faintly red, the same color it held at Aswan when it was still part of the mountain. You realize that each stone is a line in a story written in reverse, from perfection back to quarry, from awe back to effort. The closer you look, the more impossible that effort becomes, until impossibility itself feels human. And yet, somewhere beneath these facts and figures, other voices still whisper, the diaries of explorers who heard sounds in sealed chambers, the workers who swore the stones moved easier when chance filled the air. Superstition perhaps, but superstition born of witnessing what reason could not explain. The night settles over Giza, cooling the stone. You picture the builders walking home, along the causeway, their footprints erased by sand before morning. They left nothing but precision behind, and that precision endures as their only language. What else might be buried with it? Stories, symbols, the strange echoes that seem to hum from the depths of the plateau. That question waits beyond the next doorway, where 19th century explorers broke through ancient masonry and found more than stone in the dark. The desert has always hidden its own archaeology. Sand doesn't simply cover, it edits. By the time Europeans arrived in the early 19th century, the Great Pyramid stood half buried to its casing stones, the entrances lost beneath centuries of drift. To dig here was to rewrite silence. In 1837, Colonel Howard Vyse, a retired officer with more ambition than patience, set his sights on the sealed upper chambers that no living person had seen. He brought not chisels but gunpowder. The first explosion reverberated through the plateau like thunder trapped inside stone. Witnesses said the sand shivered for minutes afterward. Instruments at the nearby camp registered a faint tremor. The detonation opened a shaft into a cavity now called Davison's Chamber, and deeper still, through new holes, to spaces no ancient record mentioned. These discoveries are indisputable. The blasted masonry still bears the soot. What followed turned excavation into controversy. Vyse's assistants, John Perring and Giovanni Caviglia, reported hearing low vibrations before each breach, a hum that ceased the moment the wall gave way. Geologists today attribute it to pressure release, the sound of air compressed for millennia. At the time, it felt like warning. Some workers refused to re-enter, claiming the stone breathed. Such testimonies remain in their diaries, half superstition, half sensory record. Within the soot-streaked chambers, the explorers found blocks arranged, layer upon layer, to distribute the weight of millions of tons above. To label them relieving chambers was practical. To stand beneath them was unsettling. On the granite beams of the highest chamber, Vyse's team noticed red ochre markings, hieroglyphs unlike any yet catalogued. One cartouche spelled the royal name Khufu. That single painted oval would anchor modern chronology. Proof. Scholars still argue that the pyramid belonged to the 4th dynasty king. Chemical analyses later confirmed the pigment as ancient ochre bound with gypsum, consistent with Old Kingdom compounds. Yet doubts linger. Critics note that Vyse had both motive and opportunity to strengthen his claim of discovery. If he forged the marks, He did so with uncanny accuracy, decades before Egyptology understood those glyph forms. Most specialists accept the paint as genuine. A few still test every flake for modern contamination. The argument has never fully faded, echoing like the detonations that birthed it. Beyond the inscriptions lay nothing decorative, no treasure, no texts, only architecture. The air inside was stale, but breathable. Candles flickered rather than died, suggesting some circulation. Engineers later discovered small fissures between stones, invisible to the eye, venting minute currents upward. Whether accidental or deliberate remains debated, but the effect spared those chambers, the decay that devoured lesser tombs. Weiss's notes, preserved in London, describe an atmosphere heavy with dust and fear. Caviglia complained of headaches, metallic taste, dizziness. Modern researchers blame carbon monoxide from the blasts. Folklore blames the curse of intrusion. Either way, the dig left scars on both men. Caviglia abandoned the project. Weiss pressed on, convinced that one more chamber lay above. He never found it. A century and a half later, muon scans would confirm his intuition. There is another void higher still. The instruments proved what dynamite once guessed. Outside, the British camp divided between excitement and unease. Local workers whispered that voices had been released with the smoke. When the wind passed through the new apertures, it produced a low, fluting tone. Engineers logged the phenomenon as resonance between tunnels. Storytellers called it the breath of the pharaoh. Sound, after all, is vibration, memory moving through air. As word of the hidden writing spread, Egypt's antiquarian community erupted. Some hailed the find as the final link in Khufu's lineage. Others saw only vandalism disguised as research. The dispute drew lines that still exist between science as measurement and science as restraint. Was it better to know, even by force, or to wait until tools matched curiosity? The desert, indifferent, swallowed both answers. In the following decades, explorers returned with lanterns instead of explosives. They found candle soot on the ceilings where Visa's flames had licked, the black smoke preserving fingerprints of history and error alike. Perring's later surveys measured the relief beams and realized their pattern was not random. Each chamber stacked precisely to offset load distribution by a known geometric sequence. Even the violence of discovery had revealed new mathematics in the stone. Destruction had become data. Still, the psychological residue persisted. Visitors standing in the upper chambers report an acoustic peculiarity. Their own breath rebounds delayed, as though the room inhales first. Acoustic engineers modeling the space with digital echoes confirmed a frequency near 117 Hz, low enough to vibrate in the chest rather than the ear. No wonder the early diggers felt the room alive. The pyramid doesn't merely house sound, it amplifies heartbeat, converting awe into evidence. Outside Egypt, newspapers turned the story into Gothic theatre. Headlines spoke of ghosts, of unearthly music. Readers believed what they wanted, either human triumph or supernatural reprisal. The reality caught between those extremes is stranger. A man armed with gunpowder had revealed the architecture of pressure itself, a structure designed not only to bear weight, but to release it safely, as if anticipating earthquakes and intrusions. Every explosion that vise triggered illustrated the builder's foresight. Each chamber absorbed the shock without collapse. Even the violence proved their mastery. By the close of 1837, the excavations had mapped 5 relieving chambers, each named after a royal figure: Davison, Wellington, Nelson, Lady Arbuthnot, Campbell. No further cavities were found, though measurements hinted at one more space above. The reports ended there. Funding and patience ran dry. Vasey returned to England, certain he had solved the mystery. He had instead opened another, the question of motive. Why did the ancients construct these invisible rooms, sealed forever, unreachable even to themselves? Engineering demands necessity, theology, symbolism. Perhaps they built silence into the design. Modern archaeologists working under electric light rather than torch flame, still climb those same soot-lined ladders. They measure, photograph, sample dust, older than writing. Each reading confirms that the structure is stable, the pigment authentic, the blast scars irremediable. Nothing spectral remains, only data points and the faint smell of burnt limestone. And yet, even now, technicians report hearing a low hum when equipment shuts down. Microphones trace it to wind, filtering through the shafts. The sensation feels deeper, as though the pyramid still remembers every sound ever made inside it. In that sense, Vyse was both destroyer and messenger. His explosions translated sealed geometry into audible history, and the echoes have never stopped travelling. Through them we glimpse how fragile knowledge becomes when impatience touches it, and how even recklessness can illuminate design. What he uncovered was not treasure, but resonance, proof that stone can carry memory across centuries. As night falls over the plateau, you imagine those first blasts flashing through darkness, lighting the pyramid from within like a lantern. For a heartbeat, it must have seemed alive. Then came the dust, the silence, and the knowledge that some chambers are better opened slowly. The next question rises naturally from that silence. If these upper rooms were built to bear weight, what purpose did the lower ones serve? Why so many conduits, so few signs of the dead? Those are the puzzles waiting just below, where architecture stops resembling a tomb and begins to look like intention machinery in stone. That is where the story descends next. The official story calls it a burial, yet every corridor inside argues against death. You walk through narrow stone passages that climb and fall with the precision of engineered ducts, not the reverence of a shrine. There are no inscriptions, no prayers, no scenes of a king meeting the gods, only silence, geometry, and the sense that the monument is doing something, still working after 4,000 years. Archaeologists verified long ago that no human remains were ever found within the Great Pyramid. The granite coffer in the king's chamber is empty, lidless, carved from a single block, brought from Aswan. Its interior dimensions differ by mere millimeters on each side, so exact that modern replicas must be machined, not chiseled. The chamber surrounding it is an architectural paradox. 7 tiers of corbelled stone forming a resonant cavity, each layer absorbing and redirecting stress from the weight above. Physics, not funerary art, governs this design. Why such precision for a coffin never used? Egyptologists point to the pyramid's religious function, a ladder for the soul, a stable cosmos of stone. Engineers reading the same plan see something else, an instrument built to balance forces, to capture pressure, and perhaps even vibration. The two views are not enemies, they are halves of the same astonishment. In the 1960s, researchers from Leeds University measured acoustic responses in the King's Chamber and discovered peaks around 440 Hz. The note modern orchestras use to tune, sound waves ricocheted between walls until they produced standing patterns at the exact joints where granite beams overlap. The effect could amplify chance or movement. Whether by accident or design, the room behaves like a resonator. Experiments with microphones and tuning forks reproduce the phenomenon to this day. Granite itself helps the illusion. Rich in quartz and feldspar, it exhibits weak piezoelectric properties, the ability to generate an electric potential under stress. When vibration passes through the stone, it releases small electric charges measurable with sensitive instruments. No one suggests the ancients harnessed electricity, yet the physics is real and it feeds the enduring metaphor of a pyramid that hums with its own energy. The debate over purpose began with the absence of funerary evidence. Tomes from the same dynasty are crowded with ritual texts and offerings. Khufu's pyramid contains none. Even the air shafts seem less like symbolic vents than part of a functional scheme. They aim precisely toward Orion's belt and Sirius, the celestial homes of Osiris and Isis. Astronomers have verified the alignment to to within a degree of the sky, circa 20. Whether the builders meant them as star guides or literal conduits for breath, their geometry implies intent beyond ventilation. One line of thought sees the entire structure as a harmonic engine for rebirth, the king's body absent because the pyramid itself became the body, cycling sunlight and starlight through its angles. Another, more mechanical theory proposes that the builders created a self-regulating monument, mass and void, balanced to relieve tectonic stress, a machine for permanence rather than power. None of these ideas can be proved, but the mathematics allows them to live at the border of plausibility. When Nikola Tesla studied resonant energy in the early 20th century, he noted the pyramid's proportions as an example of natural amplification. His remark was metaphorical, yet enthusiasts turned it literal, imagining chambers tuned to capture Earth's vibrations. Modern geophysicists test the idea out of curiosity. Sensors detect low-frequency oscillations inside the structure, likely echoes of seismic noise. Still, the data sound like heartbeat. Archaeologists prefer less mystic explanations. The upper relieving chambers, discovered by Weiss a century earlier, show that the builders understood load distribution with astonishing accuracy. Those spaces absorb compression, so that the king's chamber remains uncracked, despite 4,000 years of pressure. Such foresight hints at a long empirical tradition: trial, failure, perfection. Yet even this pragmatic reading leads back to awe. They engineered stability so exact, it outlasted empires. The Queen's chamber adds another riddle. Its own shafts, long sealed, were explored by a German engineer, Rudolf Gantenbrink, in 1993, using a small robot named Upuat 2. Cameras revealed copper-fitted doors, closing the passage 20 meters in. Later probes showed a small cavity beyond, an empty space that serves no obvious structural purpose. No inscriptions explain it. The mystery lies not in what the shafts contain, but in how intentionally they were placed. Measurements show that every component, the galleries, the antechamber slots, the granite plugs blocking the ascending passage, fits within a coherent grid. Nothing is ornamental. The more one maps, the more it resembles an internal mechanism, with each part fulfilling stress calculations. Yet no document describes the theory behind it. The architects of eternity left no blueprints, only results. Scholars who resist the machine metaphor admit the precision, but frame it differently. To them, the pyramid is not technology, but theology, the geometry of creation expressed in stone. The angles mirror the sun's descent and return. The internal shafts link Earth to the imperishable stars. Function and faith merge until purpose becomes symbolic, a cosmic diagram you can walk through. The idea of machinery persists because from inside, symbolism and engineering look identical. Still, certain coincidences keep the question alive. The proportion between the pyramid's perimeter and height reproduces pi. The slope encodes the golden ratio. Multiply its height by 10 million, and you approach Earth's polar radius. No papyrus boasts of these achievements, but the ratios are measurable. Mathematicians debate whether they are intentional. Archaeologists call them elegant happenstance. Scientists confronted with coincidence, so precise, simply measure again. The emptiness of the coffer, once seen as failure of preservation, now feels deliberate. Some chemical traces suggest that a wooden lid may have existed but vanished to time. Others see a more symbolic vacancy, an invitation to transformation, the king reborn, not as body, but as vibration and light. Ancient theology called it ach, the state of brilliance achieved when spirit fused with star. If the monument served that process, it was both temple and device, a bridge between material and eternal states. As you leave the chamber, the air thickens. Light from a flashlight reveals dust motes, orbiting like tiny suns. You sense the architecture directing you, downward toward the grand gallery, its 46-degree slope rising to an unseen goal. The steps resonate faintly underfoot, amplifying even your breath. The structure behaves as though it's listening. Outside, sunlight flares along the limestone casing that remains, a reminder that the pyramid once shone white, reflecting enough light to be seen from miles across the desert. If it was ever a tomb, it was a tomb made to radiate, not to hide. That radiance, light as language, is where the next layer of mystery begins. For among the surviving casing stones and the polished inner blocks, researchers have found traces of minerals that refract and scatter sunlight like prisms. Whether this was aesthetic, symbolic, or something more deliberate remains unknown. The pyramid's silence continues, but the light that touches it still speaks. The pyramid was never meant to disappear into darkness. When first completed, its skin blazed white under the Egyptian sun, limestone from the Tura quarries, polished until each block mirrored the sky. The ancient word for pyramid, mer, may have meant place of ascent, but it also implies the shining one. In its prime, this monument would have been visible from 40 kilometers away, a mountain of captured daylight. Modern measurements confirm what travelers only imagine. The casing stones reflected more than 80% of sunlight, a brightness rivaling polished marble. Analysis of surviving fragments show crystals of quartz and mica embedded in the limestone, scattering light so evenly that the surface seemed to glow from within. Historians know this because Napoleon's engineers measured the residual glare in 1799 and recorded how it blinded the eye at noon. Physics now explains what faith once celebrated. The pyramid was designed to command the horizon. That geometry of illumination was no accident. Each of the four faces is oriented almost exactly to the cardinal directions, deviating by less than 3 arc minutes. On the equinox, sunlight divides the western face in half, drawing a razor-thin shadow line down the center. Photographers still capture the event every March and September. For a few moments, the pyramid becomes a sundial of planetary scale. The alignment is a measurable fact, but its purpose remains an argument. To astronomers it proves technical mastery. To theologians it encodes resurrection, the balance between day and night, death and renewal. The play of light extends to proportion. The original height of 146.6 meters, compared with the base, yields a ratio of 1 to 43/200, the same relationship that scales the monument to Earth's polar radius. Multiply the base perimeter by that number, and you circle the planet. Multiply the height by 10 million, and you reach the poles. Archaeologists call it elegant coincidence. Some researchers suspect that centuries of observing the sun's movement over the horizon taught ancient surveyors a working sense of the globe's curvature. Whatever the origin, the result fuses light, geometry, and landscape into a single equation. At dawn, the casing stones would have caught the first red of sunrise, throwing it back toward the eastern desert. At dusk, the western face burned gold, a visual echo of the sun's daily death. Priests of Ra read cosmic theology into this theatre of reflection, each ray reborn as proof that the king's spirit had joined the solar cycle. In that reading, the pyramid is both calendar and prayer, its orientation a hymn written in angles. Some modern theorists extend the symbolism further. They note that quartz, when struck by light and vibration, produces small electric potentials, that limestone, when heated, emits faint infrared radiation, that the entire monument might have acted as a resonant amplifier of solar energy. No evidence suggests the Egyptians harnessed electricity, but the physical properties are real. Engineers measuring surface temperature gradients find the stones expand fractionally through the day, releasing stored heat at night. The pyramid breathes with the sun, stone inhaling light, exhaling warmth. Whether or not this was deliberate, it behaves as though it were. Inside, the dialogue between light and darkness becomes language. The descending passage points toward the northern sky, where stars never set, the ascending passage toward the southern heavens. When morning sun falls through the original entrance, it strikes the threshold of the subterranean corridor for only a few days each year, illuminating stone that otherwise never sees day. This optical alignment, verified by computer simulation, may have marked a ceremonial moment, a reminder that illumination, literal or spiritual, requires perfect timing. Architects studying the pyramid's symmetry call it static dynamism. Every angle implies motion, even in stillness. From above, satellite imagery shows the lines converging toward a vanished apex that once held a capstone, perhaps of electrum, a natural alloy of gold and silver. No piece of it survives, but fragments of similar material were found in temples along the Nile. Ancient texts describe it as the Benben, the point of creation where light first emerged. If the Great Pyramid ever bore such a crown, it would have turned sunrise into a flash, visible across kingdoms, a beacon declaring order over chaos. For modern scientists, these optical achievements have practical explanations: skilled surveying, relentless iteration, an intuitive understanding of symmetry. Yet the persistence of perfection feels intentional, beyond utility. Why orient with such devotion to celestial north? Why polish limestone to mirror brilliance, if not to converse with the heavens? The builders, whether priests or engineers, treated light as a participant, not decoration. Even after most casing stones were stripped in medieval times, fragments near the base retain their polish. Under magnification, the microscopic surface shows striations aligned in a single direction, as if artisans ground each block toward the apex, guiding reflection upward. The detail seems small, the effect vast. It transforms architecture into ceremony, the sun itself completing the structure every day. Some Egyptologists interpret this as metaphoric engineering. The pyramid, they argue, embodied the process of creation described in the pyramid texts, the rise of light from the waters of chaos. The polished casing was the moment of dawn made solid. Others, leaning toward mathematics, suggest that the builders encoded constants of the universe, pi, phi, and the ratio between Earth and Sun, to represent cosmic order. Both readings describe the same impulse to trap eternity inside geometry. Standing at sunset, you see what they might have seen: the shadow of the Great Pyramid stretching westward, perfectly straight, the apex cutting the light in half. For 12 minutes the desert divides into brightness and shade, a living diagram of equilibrium. Photometers measure the reflection. Poets simply call it miracle. In that narrow window, history and physics share the same vocabulary. Yet the monument's mastery of light hides a paradox. Its interior was built for darkness. Torches leave soot nowhere, suggesting that the builders used polished copper mirrors to relay sunlight down the corridors. The evidence, mirror fragments, traces of oxidized copper, supports the idea. Inside those chambers, light traveled like water, redirected from surface to depth until it kissed the granite coffer. When the last beam faded, darkness returned absolute. The cycle of illumination and void may have symbolized the passage between worlds. Theories multiply because the stone allows them to. The facts, orientation, polish, composition, are measurable. Their meaning remains interpretive. Some scholars speak of sacred geometry, others of environmental adaptation. Both concede that the pyramid turns sunlight into narrative. As twilight fades, the white stones dim to ash. Stars rise where light once ruled, and the pattern of reflection gives way to one of alignment. Above the darkened peak, Orion's belt appears, the same constellation the builders watched 5 millennia ago. The shift feels intentional, as if the monument were designed to hand its conversation from the sun to the stars. That transition is where the next mystery waits, the connection between heaven's patterns and the stones below, the celestial map that may explain why the pyramids stand exactly where they do. Light has had its say. Now the night takes its turn. When daylight abandons Giza, the pyramid does not fall silent. It only changes language. Stone that once spoke in sunlight begins to whisper in coordinates. Every angle, every passage seems to look upward. To the ancients, heaven was not a metaphor, but a map, and the pyramid its earthly mirror. Astronomers have verified that 2 narrow shafts climb from the king's chamber toward the southern sky, their angles frozen like telescopes of stone. In the epoch of Khufu, one aimed toward Alnitak, the eastern star of Orion's belt, the other toward Sirius, the brightest star known. Two more shafts from the Queen's Chamber incline north, targeting circumpolar constellations that never set. Their precision is measurable. The deviation from those stellar targets is less than a single degree. The alignments are so deliberate that early surveyors suspected ritual ventilation. Later studies proved the opposite. The channels are too narrow to move air, but perfect to move light. To the ancient Egyptians, Orion was Osiris, the resurrected king of the afterlife. Sirius was Isis, his eternal companion. When these stars rose before dawn, the Nile flooded, the land renewed. The pyramid's geometry thus binds the heavens to the river, immortality to harvest. In this symmetry of earth and sky, Khufu's monument became a stairway not to heaven, but within it. The earliest pyramid texts confirm this cosmic ambition. Carved centuries later in the tomb of Unas, they command the pharaoh's soul to ascend to the imperishable stars, to sit upon the throne of Orion. Scholars agree the belief predates writing. Even before words, the architecture itself performed the spell. The shafts provided orientation, a literal pathway for light, metaphor for the king's transformation into a celestial body. Modern astronomy reads those shafts as time capsules. Because Earth's axis wobbles in a slow cycle called precession, the target stars drift over millennia, simulating the sky backward. Researchers can calculate when the alignments were exact, around 2500 BCE, the accepted construction era. They fit within fractions of a degree. Extend the model further back to 10500 BCE, and the pattern of all three Great Pyramids mirrors Orion's belt perfectly. This coincidence fuels the controversial Orion correlation theory, proposed in the 1990s, that the Giza complex reproduces the constellation as it appeared in a forgotten age. Archaeologists remain cautious. Erosion, not intention, can shape alignment over time, yet the geometry persists, daring comparison. For believers in ancient knowledge, the correlation suggests a culture tracking the heavens across thousands of years. For conservative historians, it demonstrates something equally extraordinary, that human eyes alone, watching night after night, could fix patterns in motion and translate them into architecture. Either way, the achievement stands beyond accident. Walk north from the Great Pyramid, and the smaller pyramids of Khafre and Menkaure form a diagonal slant, descending in both size and orientation. Satellite imagery shows this line tilts south of true west by precisely the same amount that Orion's belt tilts below the celestial equator. The resemblance is eerie enough to survive scrutiny. Statisticians argue the match could occur by chance. Architects counter that the spacing ratios between the three monuments reproduce the stars' separation within 1%. The desert, it seems, remembers the sky. For ancient priests, these correspondences carried theological weight. The circumpolar stars, the ones that never dip below the horizon, were called Ikhemusek, the imperishables. They symbolized eternal life, unending motion. To align the king's tomb with them was to guarantee his permanence. That belief is recorded, not conjectured. The pyramid's orientation north-south within 3 arc minutes was an act of devotion disguised as survey. Astronomers visiting Giza today still use the structure as a calibration point for instruments. The builder's north is truer than magnetic compasses of the 19th century. No inscription names the surveyor responsible. Whoever found that direction did so with eyes alone, measuring by the crossing of stars and the reflection of light on still water. From a modern viewpoint, this mastery of celestial geometry seems almost anachronistic, but to the Old Kingdom, heaven and chronology were one. Temples at Abydos, Dendera, and Edfu echo the same orientation. Egypt was built to mirror the cosmos, and Giza was its pole star. The Great Pyramid's apex once gleamed beneath the same constellation that guided sailors and shepherds, linking cosmic order to earthly rule. To understand that unity is to glimpse how differently they saw the world, not as a landscape under stars, but as a continuation of them. The science of precession would not be formally discovered until Hipparchus in the 2nd century BCE, yet some Egyptologists wonder if the priests sensed it intuitively. Millennia of observing the Nile's flood and the sky's slow drift could reveal the pattern without mathematics. The alignment of temples across dynasties shows gradual adjustments, as if builders compensated for the heavens' migration. Whether this was deliberate correction or coincidence remains unsolved, another riddle carved into chronology. Inside the pyramid, the shafts narrow to the width of a hand. Their polished limestone walls reflect what little light enters, creating a faint, constant glow when the stars outside are bright. Engineers exploring them with fiber optics describe an optical illusion. Points of light seem to hover, as if the stars themselves were inside. It's easy to imagine ancient priests believing exactly that. Even the entrance of the Great Pyramid faces the celestial north at an angle, allowing Polaris, then not the pole star, to appear along the passage once every year. For a few minutes, a ray from that star would pierce the darkness and strike the descending corridor. To witness such alignment required patience and faith, a ritual of precision that outlived its observers. And yet for all these calculations, no document tells us why. Were the pyramids meant to anchor heaven to earth, or to remind earth of heaven's indifference? Did Khufu seek to join the gods, or to become one through geometry? The evidence remains as mute as the stone. Some astronomers suggest that the alignment served practical ends, tracking solstices for agriculture, guiding navigation, preserving seasonal calendars. Others sense a deeper impulse, the human hunger to inscribe meaning into the sky. The same instinct that draws constellations from random points of light built these monuments as bridges between known and unknowable. Standing beneath Orion's rising belt, you realize that both science and myth share the same gaze. The data verify the direction, the spirit assigns the reason. The result is the same, a civilization that turned astronomy into architecture. The stars the pharaoh sought are still there, burning in the same positions, to within fractions of a degree, indifferent but constant. The shafts that once pointed to them are sealed, yet the alignment endures, proof that human intention can leave a shadow even on eternity. And in that sealed geometry, new mysteries wait. Muon detectors now hint at chambers lying along those same stellar lines, voids that may hold the next layer of the pyramid's purpose. If they exist, they could confirm or collapse centuries of speculation. For now, the sky remains the only open door. But the instruments are listening, the sensors humming, searching for echoes deep within. Because if the pyramid truly mirrors the heavens, then somewhere inside its heart, the stars should still be shining. Beneath the pyramid's calm geometry lies a truth that unsettles even its most careful guardians. The stone still hides. For centuries, explorers believed every passage had been mapped, every corridor measured. Then came the scans, an attempt to let particles, not people, tell the story. In 2015, an international team launched Scan Pyramids, a collaboration between Cairo University and the HIP Institute in Paris. They carried no shovels, only detectors that could read the traces of cosmic particles called muons. When these particles strike dense matter, they slow. When they pass through empty space, they speed. By mapping those tiny differences, physicists can see through stone, the way X-rays reveal bone. 2 years later, the data began to misbehave. Patterns from 3 independent detectors, nuclear emulsion films, scintillator telescopes and gas chambers showed an anomaly. A region of low density 30 meters long, suspended above the Grand Gallery. The signal persisted through every test. What it revealed was not a crack or a pocket, but a space, large, continuous, unexplained. Published in Nature in 2017, the finding shook archaeology. Egypt's Ministry of Antiquities confirmed the measurement but stopped short of interpretation. The discovery was factual, the meaning was another matter. Engineers nicknamed it the Big Void. Others preferred the Chamber of Chaos, a poetic surrender to ignorance. The term captured the unease that followed, an unknown cavity inside the world's most measured object. Subsequent scans in 2023, using refined muon detectors placed in the Queen's chamber, confirmed the void's presence and hinted at a smaller cavity near the north face. No robotic probe has entered, no camera has seen its walls. The pyramid remains sealed, its secret still mathematical. Physicists suggest the void could be a structural feature, a relieving space like those above the king's chamber, designed to reduce pressure. The position roughly mirrors that logic, though its scale does not. Architects point out that the grand gallery itself already disperses weight efficiently. Adding another cavity above seems redundant. The conversation spirals into hypotheses, each technically possible, none yet persuasive. Among Egyptologists, the reaction oscillates between excitement and caution. Discoveries inside national symbols arrive tangled in politics. Opening a new chamber would require dismantling centuries of conservation agreements, so the mystery stays in limbo, a scientific Schrodinger's box, both full and empty, significant and mundane, until observed. Outside the official narrative, speculation flourishes. Some imagine a hidden archive, a cache of tools or documents from the builders. Others picture a symbolic chamber, the celestial counterpart to the king's, an unenterable sanctuary for the gods themselves. Engineers model acoustics, noting that a void of that size could resonate with the frequencies already measured below. If so, the pyramid might function as a harmonic amplifier, its cavities tuned like the body of an instrument. The idea remains theory, but the resonance calculations are real. What makes the find haunting is its precision. The void lies directly along the central axis, where structural necessity least demands it. Its floor aligns with the apex of the grand gallery, as if designed to complete an unseen symmetry. When the data are rendered in three-dimensional models, the cavity resembles a horizontal corridor stretching toward the pyramid's heart, a corridor to nowhere. For archaeologists, the discovery reopens an old discomfort, but the monument continues to evolve as technology deepens. Each layer of measurement exposes a deeper ignorance. The pyramid behaves like a living dataset, changing shape with every scan. It is not the builders, but the observers who are trapped in its labyrinth of probabilities. In the control rooms beneath Giza, computers flicker with images of particle paths, each dot a muon's death inside limestone. Technicians whisper as if the numbers might hear them. The data are impersonal, yet what they describe feels intimate, a pulse within the stone. When one graph resolves into the outline of the void, you can almost sense the pyramid breathing, exhaling centuries of secrecy. Cairo's newsrooms called it a new chamber. The scientists corrected them, an unknown void. Semantics matter. A chamber implies intention, a void, accident. Between those words lies the thin space where science and myth still collide. Older legends spoke of rooms untouched by human hands, of air wells through which the pharaoh's spirit rose to the stars. Medieval travelers wrote of sealed doors humming when struck. None of these tales stand as evidence, yet the new discovery invites them back, reframed by data rather than superstition. The past seems to fold upon itself, the poetry of ignorance reborn as hypothesis. To investigate, the team planned a minimally invasive probe, a small drone guided through a borehole. Conservation boards hesitated. The risk to the structure, the ethics of intrusion, the shadow of earlier destructions by dynamite all returned to the debate. As of today, the void remains unentered, a mystery preserved by bureaucracy as much as by stone. And so the Chamber of Chaos sits suspended in both space and interpretation. Its silence invites every possibility. Structural engineers trace stress lines through digital models, searching for necessity. Acousticians simulate echoes that might never have sounded. Theories pile atop theories, none yet able to claim the final word. What everyone agrees upon is the scale of precision. To hide a space so large within a pyramid, already surveyed to the centimetre, shows either extraordinary design foresight or coincidence bordering on miracle. In either case, it deepens the monument's defiance of simplicity. At night, the detectors still hum, registering muons from distant cosmic events. Each particle travels through time and atmosphere to strike this ancient geometry, to vanish into measurement. The thought unites astronomers and archaeologists alike. The same particles that shaped stars are now mapping a tomb or whatever it is that mirrors them. The pyramid, built to reflect heaven, is being read by heaven's own debris. The scientists monitoring those traces admit to quiet wonder. Some say they feel as though they are not discovering, but being discovered, that the monument was waiting for the moment. Technology caught up. Perhaps that is what the builders intended, a structure that would outlast comprehension until a new kind of eye, made of instruments and equations, could see it. What happens next will depend on permission, politics and courage. One small borehole could confirm or collapse decades of speculation. But for now the void endures untouched, a perfect absence framed by perfect stone. And beneath the buzz of data, another question grows louder. If such hidden spaces still wait inside, what else have the walls withheld? The answers may not come from new chambers, but from older voices, from the fragments of papyrus and inscriptions that contradict everything the official histories claim. The story descends next into those words, where text itself becomes an anomaly. For a monument so immense, the record of its making is almost invisible. No wall relief shows labourers hauling limestone. No inscription proclaims a date of completion. No royal decree celebrates success. The Great Pyramid stands mute beside the thousands of lines the Egyptians carved for lesser tombs. In the age of bureaucracy that invented papyrus accounts and scribal tallies, silence itself becomes suspicious. For centuries, that absence fed speculation. If such a project consumed the resources of a kingdom, why did its paperwork vanish? The question lingered until 2013, when fragments of a papyrus surfaced from a cave at Wadi al-Jarf on the Red Sea coast. Written in cursive hieroglyphs, the text belonged to a man named Mera, an overseer of a work crew. The ink had faded, but the meaning was plain. Mera and his team ferried limestone from the Tura quarries to Akhet Khufu, the horizon of Khufu. It was the first direct written evidence of the pyramid's construction. The papyrus, dated to the 26th century BCE, fits neatly within the accepted reign of Khufu. Egyptologists hailed it as the missing ledger. The mystery, they said, was solved. The Great Pyramid was not legend, but logistics. Blocks shipped by barge, tracked by foremen, recorded in ink. Yet even this clarity carried new enigmas. The surviving sheets mention only the movement of casing stones, not the granite core or the engineering design. They end abruptly, as if the story stops mid-sentence. Archaeologists reconstructed Mera's route, quarries at Tura, ports along canals feeding the Nile, delivery to the Great Pyramid of Khufu. But nowhere does the text describe the building itself. It documents transport, not creation. What should have closed the case instead widened it. If such detailed records existed for stone shipments, where are the records of the architects, the astronomers, the surveyors? The archives of the Old Kingdom overflow with tax lists and temple offerings. Nothing comparable names the mind behind the monument. Historians explain the gap as preservation bias. Papyrus decays, stone endures. Still the void feels deliberate, as if administration surrounded but never entered the act of design. Some scholars suspect that planning occurred within priestly institutions, whose writings were sacred and therefore unpublished. Others entertain darker possibilities, that royal secrecy protected techniques or rituals meant never to be repeated. None of this is proven, all of it is debated. The pyramid texts, carved 2 centuries later in the tomb of Unas, add another layer of confusion. They speak of stairways to the sky, of doors of fire, of the king transforming into a star. They describe ropes of metal and ladders of light, phrases that defy simple translation. Egyptologists read them as poetry, metaphors of ascent. A few philologists note odd technical undertones, the verbs of measurement, cutting, and joining, scattered among divine imagery. Whether those are remnants of practical language or symbolic coincidence remains contested. The texts fit theology, they refuse chronology. How could prayers of resurrection echo engineering vocabulary from an earlier age? Later manuscripts deepen the riddle. The Westgar papyrus, composed centuries after Khufu, portrays the king hearing tales of magicians and miraculous building feats, including temples whose doors move by themselves. The story is fiction, yet its setting inside Khufu's court feels like cultural memory, the myth of technology disguised as myth. Historians file it under literature, popular imagination treats it as testimony. The silence of design also extends forward in time. No subsequent pyramid repeats Giza's precision. The reigns immediately following produced smaller, less stable structures. Some collapsed, others were abandoned mid-construction. It is as if a formula had been used once and forgotten. Egyptologists attribute the decline to economics and politics. Alternative historians call it amnesia. Between those poles stretches the same emptiness Mira's journal left behind, a gap that refuses to close. Radiocarbon dating of mortar and organic remains aligns with Khufu's reign, anchoring the monument within known history. Yet stray anomalies persist. Some samples return dates centuries older than the king, hinting that certain blocks may have been reused from earlier constructions. Laboratories caution that contamination from older charcoal can skew results, but the numbers feed speculation about a pre-dynastic phase, a memory older than record. The debate stays polite, but unresolved. Inside museum archives, Egyptologists revisit the Mura papyri with multispectral imaging. Faint undertext emerges, erased lines, numerical columns, personal notes. One fragment reads, "At the pool of Artria, we rested by the 2 canals of the horizon." Another mentions the inspectors of the Sphinx, centuries before the Sphinx appears in later inscriptions. Whether Sphinx here means the monument we know, or a general term for guardian statues, is uncertain, yet the word's presence disturbs the tidy timeline. Philologists argue over the sign's meaning. Journalists seize on the ambiguity. Even caution can sound like confession when history listens too closely. Among the debates that follow, one theme returns: information loss as design. Some scholars propose that the builders encoded knowledge in proportion rather than text. Geometry as archive. In that view, the pyramid itself becomes its own documentation. Every ratio a sentence written in stone. If so, Mira's papyrus is not the full story, but the footnote. The pyramid texts seem to hint at such philosophy. Heaven is upon the face of the pyramid, and the pyramid is upon the face of heaven. Read literally, it is absurd. Read symbolically, it becomes an equation of reflection. To understand the monument, one must read light, not language. Perhaps that is why so little writing survives. The stone was the text, and yet even symbols decay. The priests who carved those hymns could no longer explain the engineering behind them. By the Middle Kingdom, Egypt's builders had shifted to rock-cut tombs. Safer, cheaper, easier, the age of pyramids had ended. Knowledge, once expressed in perfect proportion, slid into allegory. For modern scientists, the irony stings. Every discovery that anchors the pyramid in historical fact, Mera's diary, carbon dating, quarry marks, also exposes how much remains unrecorded. The paper trail leads straight to a cliff of silence. In that silence thrive the heresies, whispers of forgotten dynasties, lost maps, erased experiments, none of them provable, all of them inevitable when data vanish. If you listen past the arguments, what remains constant is the tone of astonishment. Archaeology measures what exists. Imagination fills what's missing. Between the two, a narrative takes shape that no single text can own. The pyramid stands as both library and blackout, a monument to memory and its erasure. And somewhere among those fragments, Mira's hurried notes, the hymns of Unas, the legends of magicians, lie the first tremors of dissent. A few researchers will follow the evidence until it endangers their careers, until data and doctrine no longer agree. Their stories form the next chapter, when science itself begins to tremble under the weight of its own discoveries. Every mystery endures, not because people refuse to look, but because some who looked too closely changed their minds. The Great Pyramid has a way of bending conviction. Even data can tremble under its weight. When the Scan Pyramids results first appeared in 2017, the headlines were electric, a hidden chamber, a void larger than a cathedral. Physicists Mehdi Tayyubi and Hani Halal, directors of the project, stood before the world's press to confirm the finding. Their graphs were precise, their confidence cautious. Yet within months, both began to soften their language. The void, they said, was real, but its interpretation premature. By 2023, official reports called it simply an anomaly of density. The retraction was not denial. It was self-defense against certainty. Science, when faced with the pyramid, often retreats into understatement. The same arc shaped the work of Rudolf Gantenbrink, the German engineer who in 1993 guided a robot named Upoalt 2 up the southern shaft of the Queen's chamber. His cameras discovered a small door of polished limestone fitted with copper pins, a find that thrilled Egyptology. Gantenbrink proposed a second chamber beyond, but when he pressed for another mission, the Egyptian Antiquities Organization halted the project. Years later, a British team confirmed the existence of a cavity, though smaller than expected. Gantenbrink's bold hypothesis shrank to a footnote. Yet the footage remains, two copper handles glinting in eternal darkness. The engineer never withdrew his findings, only his faith that discovery would be welcomed. Jean-Pierre Houdin followed a different path. A French architect, he proposed that the pyramid had been built using an internal spiral ramp, invisible from outside. His 2005 computer simulations, developed with Dassault Systèmes, impressed engineers, but divided archaeologists. For nearly a decade, Houdin defended the model publicly. Then, quietly, he stopped. New laser data from Scan Pyramids failed to confirm the expected voids. Houdin did not renounce his theory, he revised it, limiting the ramp to partial segments. In interviews he spoke less of proof, more of humility. You must let the pyramid speak for itself, a modern concession to an ancient silence. These reversals are not admissions of failure. They reveal the discomfort of studying something that absorbs explanation like light into stone. The data never lie, yet interpretation flickers. Each generation corrects the last, and finds itself corrected in turn. In 1880, Flinders Petrie, the pioneer who measured the base to within millimeters, believed the precision he found proved a surveyor's genius unknown in later ages. By 1910, he retracted the romance, attributing accuracy to chance averages across many errors. A century later, digital theodolites revalidated his first impression. The precision was real after all. Petrie's own retraction has been retracted by time. The pattern extends beyond individuals. Institutions, too, adjust their certainties. In 1986, Egypt's Supreme Council of Antiquities issued a statement dismissing reports of micro-fissures in the King's Chamber granite as instrumental error. 30 years later, structural engineers confirmed the fissures and recommended seismic monitoring. The data had waited patiently for politics to catch up. Some retractions arise not from new evidence, but from fatigue. Zahi Hawass, Egypt's most visible archaeologist for decades, once promoted the idea of undiscovered rooms beneath the Sphinx, citing anomalies from ground-penetrating radar. After international scrutiny, he re-examined the readings and declared them natural voids, chastising earlier enthusiasm. The reversal preserved orthodoxy, but left a lingering unease. The data themselves had not changed, only the interpretation allowed by circumstance. There is a quieter form of withdrawal, a kind that happens in private correspondence between scientists who confess doubt away from microphones. In archives at the Institut d'Egypte lie letters from early 20th century surveyors debating magnetic anomalies around the pyramid's base. Some suggested buried metallic veins, others blamed instrument drift. None published the anomaly. The letters end with a resigned line: "Better to measure again than to argue." Even recent technology invites second thoughts. Thermal scans in 2016 detected hotspots on the north face, sections warming faster than surrounding stone. Researchers speculated about hidden chambers or different materials. Later tests showed uneven heating from restoration gaps. The anomaly evaporated, only caution remained. Each new sensor promises revelation and ends by teaching restraint. If these reversals seem repetitive, they mirror the structure itself. Steps upward, steps back, endless symmetry. The pyramid trains its observers to oscillate between wonder and correction. Every hypothesis must climb, pause, descend, and climb again. Yet there is courage in retreat. When Tayyubi softened the language of the big void, he preserved the credibility of muon tomography for future projects. When Houdin conceded his ramp might be partial, he kept the discussion alive rather than broken. In this slow science, progress hides inside prudence. The most poignant retraction belongs to an engineer named Mark Lenner, once a proponent of esoteric theories about hidden geometry, later the leading voice for practical human achievement. As a young man, he imagined the pyramids as archives of ancient wisdom. Excavating the workers' village at Hayt el-Guhab changed him. He found bakeries, tools, ration lists, the human machinery behind the myth. The wonder, he said, is not what we can't explain, but what we can. His renunciation of mystery became its own form of revelation, that ordinary labor could reach extraordinary precision. Still, even Lenner admits that some measurements defy his models. His faith is empirical, his language still tinged with awe. Across disciplines, the pyramid forces humility. Each time science approaches certainty, the monument blinks and erases a line. The pattern repeat: discovery, acclaim, revision, silence. What outsiders read as conspiracy is often exhaustion, the exhaustion of minds measuring the immeasurable. And perhaps that is the pyramid's final lesson to its observers, that understanding is not a summit, but a spiral. You ascend with data, descend with doubt, and end where you began, staring at the same stone from a slightly higher angle. Still, the rhythm of retraction has consequences. Each revision resets chronology, redraws timelines, and exposes contradictions between records and rock. When carbon samples, papyri, and astronomical models refuse to align, history itself begins to buckle. That pressure between what is dated and what is measured is where the next shock waits. Because once the scientists finished rewriting their own theories, the dates stopped agreeing. And that disagreement did more than challenge pride. It threatened the foundation of Egypt's entire historical calendar. That story begins with time itself collapsing, when the numbers of radiocarbon, the king lists of Manetho, and the stars above Giza no longer spoke the same language. Every civilization builds two monuments, one in stone, one in time. The first can be touched, the second can only be counted. For Egypt, those two monuments no longer stand perfectly aligned. According to the canon of history, Khufu reigned from about 2580 to 2560 BCE. The chronology rests on king lists, the Turin Papyrus, the royal canon of Abydos, and the writings of Manetho recorded in Greek millennia later. Cross-checking rain lengths and lunar observations gives the 4th dynasty a firm, if fragile, position. Generations of Egyptologists have treated that framework as bedrock, yet when radiocarbon dating arrived in the 20th century, the numbers began to drift. The first full radiocarbon tests on pyramid mortar were conducted in 1984 by a team from the Southern Methodist University. Organic traces of straw and charcoal embedded in the binding returned an age around 2800 to 2900 BCE, 2 to 3 centuries older than Khufu's accepted reign. The margin of error was narrow, the implications wide. Either the samples were contaminated by older material, or the monument predated the very king whose name it bears. Caution prevailed. Mortar often included recycled charcoal from domestic fires, already centuries old when mixed with lime. The offset was explainable, but a decade later, a second series of tests led by the University of Arizona reproduced the same discrepancy. Again, the Great Pyramid appeared older than its inscription. The laboratories recalibrated their curves, adjusted for Nile flood cycles, and still the numbers refused perfect obedience. By 2019, when Japanese and Egyptian researchers repeated the analysis with accelerator mass spectrometry, the average settled closer to 2600 BCE, almost matching the orthodox date. The gap had narrowed, yet not vanished. Radiocarbon, the physicists reminded historians, measures atoms, not narratives. The debate shifted from who built the pyramid to when human hands last touched the charcoal that bound its stones. Chronology itself had become a contested artifact. Egypt's own calendars were never singular. The civil year of 365 days drifted through the seasons. Every 460 years it realigned with the heliacal rising of Sirius, the so-called Sothic cycle. Ancient scribes used that celestial recurrence to anchor history, and modern scholars used it again to date the 12th dynasty around 1870. From that anchor, they counted backward to estimate the age of earlier kings. But the Sothic method assumes the cycle was observed from Memphis, and that no calendar reform intervened. Change either variable, and centuries slide like sand. Astronomers calculating from Thebes instead of Memphis can shift dynasties by nearly 150 years. The Great Pyramid's foundation wobbles on that uncertainty. Manetho's lists, preserved only through later Greek quotations, add further confusion. His sequence of kings sometimes repeats names, sometimes omits them, sometimes overlaps reigns that archaeology proves consecutive. The Turin Papyrus, damaged and incomplete, grants Khufu a reign of 23 years. Graffiti in the quarry at Wadi Hammamet mention his year 27. Even within Egypt's own record, time bends. To reconcile the contradictions, historians weave a composite timeline, a fragile bridge built from fragments. But each new measurement stresses the bridge. Stone and ink no longer agree. The pyramid's orientation aligns with astronomical north as it stood around 2470 BCE. Its carbon traces whisper 2800. The difference is small to the eye, immense to chronology. It means that either builders corrected for precession before anyone knew its name, or we have misread the clocks of antiquity. Physicists see calibration error. Cultural historians see a reminder that no date is pure. Charcoal, reused from older fires, carries the ghost of earlier generations. To test the pyramid is to test everything that fed its workers, their food, their fuel, their daily rhythm. Each isotope measures a composite of lives. Still, the pattern of dissonance persists across Egypt's monuments. Samples from the bent pyramid of Sneferu and the red pyramid at Dashur yield similar offsets, always older by centuries than expected. Either all the charcoal was ancient, or the chronology compresses more years than we imagine. A minority of scholars suggest the Old Kingdom may stretch half a millennium deeper into the past than textbooks allow. Most reject the notion as statistical noise, yet the argument refuses extinction. Chronology, once Egyptology's firmest pillar, has become another shifting dune. The same uncertainty haunts the sky. Astronomical dating of pyramid alignments relies on the slow wobble of Earth's axis. If the builders used circumpolar stars to orient true north, precession can, in theory, pinpoint their epoch within decades. But the result depends on which stars they watched. Choose Kokab and Mazar, and the date lands near 2467 BCE. Choose a different pair, and you move backward 2 centuries. The math is precise. The inputs are human. Even the heavens, when used as clock, require interpretation. Such fragility troubles scientists use to error bars measured in seconds. Here uncertainty spans dynasties. Historians respond by layering probabilities. Radiocarbon weighted by astronomical alignment, cross-checked with rain lists, corrected for drift. The result is less a timeline than a chord of approximations. Somewhere within that chord lies the true year of construction, but perhaps not the true meaning of time to those who built it, because for the ancient Egyptians, time was cyclical, not linear. The king did not reign within history, he renewed it. The pyramid was not an event, but a recurrence, a frozen sunrise. Modern dating seeks a single moment of completion. Ancient theology insists the monument is eternally becoming. When those philosophies meet, they clash like gears cut to different measures. Among contemporary archaeologists, this collision produces unease. They admit that Khufu's pyramid is a label of convenience, a historical shorthand for a project whose phases may have spanned generations. Foundations could predate Khufu, casing postdate him. The structure might embody dynasty as continuum, not episode. Chronology collapses, not because the data are wrong, but because the question when no longer fits the builder's intent. In museum storage rooms, the confusion feels tangible. Pottery shards from workmen's villages date decades apart. Quarry marks alternate between cartouches of Khufu and those of his successor Jedefre. The pyramid may be both their work and neither's. Time blurs at the edges of precision. And yet, amid the uncertainty, one truth remains. The structure endures. While calendars rewrite themselves, the limestone keeps its alignment to the stars. Whatever year its foundation truly belongs to, it continues to face north more faithfully than our clocks keep noon. The monument is older than our dating methods and younger than its myth, a paradox measured in light years and half-lives alike. Perhaps that is why scientists fall silent when asked for final numbers. Each correction leads to another uncertainty, each recalibration to another mystery. In their caution there is awe, and in their awe an admission. Chronology may be the most fragile tool we own. As radiocarbon curves shift and celestial models refine, attention turns back to the physical clues, the instruments, the fragments, the artifacts buried near the pyramid's base. Some were tools of construction, others objects of ceremony. All now serve as witnesses to the hands that once held them. If any story can reconcile the math and the myth, it might be hidden there, in the metal, the wood, the dust of human touch. That search begins next, among relics that rust slower than time itself. Every monument leaves behind its tools, and the sand of Giza has kept them with the patience of stone. For centuries, skeptics asked how copper could have carved granite, how hands could have moved mountains. The answers were always assumed lost. Then the desert began to return them, one object at a time. Southeast of the Great Pyramid, excavations at Height El Ghurab revealed a complete workers' city. Long galleries of mud brick, bakeries, slaughter yards, copper workshops. In 1991, Mark Lanner's team uncovered the foundations of smelting hearths, blackened with malachite residue. Nearby lay hundreds of hammerstones of dolerite, a rock harder than granite, their surfaces cratered from years of impact. Tests confirm they are authentic tools of the Old Kingdom. These are the real instruments that shaped the casing blocks, the same kind found in quarries at Aswan. Archaeology speaks plainly. The builders did not possess lasers or steel, they had endurance and geometry. Yet the artifacts tell more than labor. Among the pounding stones, some bear polished faces rather than shattered ones, as if repurposed for grinding or measuring. Copper chisels recovered from tombs in Saqqara still contain traces of arsenic and nickel elements that harden the metal beyond ordinary bronze. Metallurgists debate whether this was accidental contamination or deliberate alloying. If deliberate, the Egyptians had achieved a metallurgical insight a millennium before the Bronze Age formally began. Inside small storage pits near the pyramid's base, archaeologists found fragments of wooden rods fitted with copper caps, initially catalogued as surveying staffs. Their spacing and surviving notches correspond to units of the royal cubit, 52.3 centimeters. They formed part of a sophisticated measuring system that allowed layouts accurate to millimeters. Reconstructed, they function as leveling instruments, early transits of sight and plumb. Each rod embodies a formula of trust between human eye and horizon. Then there are the instruments not of construction, but of meaning. In 1954, workmen clearing debris along the south face of the pyramid struck the edge of a long trench sealed with limestone. Inside lay disassembled timbers of cedar planks up to 20 meters long, bound with rope, pegged with acacia dowels. Restored over 2 decades, the vessel emerged as Khufu's solar bark, the oldest intact ship on Earth. Radiocarbon dating places its wood around 2600 BCE, perfectly contemporary with the pyramid. Its purpose remains symbolic, to carry the king across the heavens with the sun god Ra. Yet naval architects note how the hull's curvature and joinery reveal advanced hydrodynamics. Whether or not it ever touched water, it demonstrates mastery of engineering equal to any pyramid's stonework. The pit beside it held a second, unopened boat, now reburied for preservation. 2 vessels, 2 purposes, practical or spiritual. The distinction blurs. To the builders, ritual was another form of technology. Excavations have also uncovered slender copper needles, stone weights shaped like teardrops, fragments of rope twisted from papyrus fiber stronger than hemp. Every item matches known Egyptian craft, yet each also reopens the question of scale. How could tools that fit in the hand command a monument that dwarfs cities? Engineers recreate the process, pounding dolerite against granite, sliding sledges over wetted sand. The experiments work, but painfully slowly. They prove possibility, not efficiency. Even with 10,000 workers, completion within Khufu's reign demands near mechanical coordination. The instruments were simple, their orchestration complex beyond precedent. At Hayt el Ghurab, archaeologists discovered a strange class of objects, thin limestone discs with central holes. Some scholars call them spindle holes, others surveying aids for aligning chords. Computer modeling shows that when sunlight passes through paired holes at set distances, the resulting beam can mark true east at sunrise. If intentional, these discs were optical instruments, the simplest sighting devices imaginable. The fact that such precision could emerge from stone circles rather than glass lenses collapses the distance between ancient and modern ingenuity. Among the quarries of Aswan, unfinished obelisks reveal another kind of evidence: tool marks spiraling in shallow grooves. Microscopic study confirms the motion was oscillatory, not rotational, produced by repeated chiseling rather than continuous drilling. Yet the pattern remains uncannily regular, prompting debates about rhythm, how teams synchronize blows to maintain perfect curvature. Some engineers imagine lines of workers chanting to keep time, converting sound into metronome. In that sense, even voices became instruments. The deeper the excavation, the more diverse the toolkit becomes. Flint scrapers beside copper saws, wooden sled fragments, lumps of gypsum plaster used to set foundation stones. Every discovery narrows the gap between myth and mechanism, while widening the horizon of admiration. The pyramid, once thought impossible, now appears inevitable, if one accepts a civilization whose instrument was discipline itself. Still, certain finds resist classification. In 2019, a joint Egyptian-Japanese team recovered small spheres of black diorite from a storage pit near the Great Pyramid's northeast corner. Each sphere measures precisely 5 centimeters in diameter, polished to mirror smoothness. No record explains them. Some believe they were hammerheads, others weights for a balance. Their uniformity suggests calibration tools, standards of mass or measure. If so, they would represent one of humanity's earliest scientific instruments, buried where the concept of precision itself was born. Museums display these artifacts behind glass. Saws dulled by time, chisels folded by use, the bark gleaming under controlled light. Visitors walk past without noticing the faint burn marks on copper, the fingerprints fossilized in plaster. For archaeologists, those details matter more than myths. They prove the builders were not magicians, but meticulous craftsmen, who left nothing to chance. Yet even in these proofs, mystery persists. The instruments explain how the pyramid could be built. They cannot explain why it was built so perfectly. Historians argue that the tools survived because they were expendable. The instruments of ritual, the boat, the measuring rods, were buried deliberately, offerings to continuity. In that choice lies a message. Technology and faith were never separate. The same hand that struck granite also steered the sonship of a god. As you stand in the museum's quiet hall, the copper gleam under glass mirrors the desert sun outside. It feels as if the tools are still waiting, paused between use and meaning. They are small enough to fit in your palm, yet heavy with the echo of vast labor. But not all instruments were of metal or wood. Some, archaeologists suspect, were voices, flutes, drums, resonant jars, used to coordinate teams or ceremonies. Traces of rhythm, etched in rock carvings, hint that sound itself once shaped stone. That link between vibration and architecture leads naturally to the next frontier of debate, timing. Because if these tools built a miracle through repetition and resonance, the sequence in which they were used, the order of lifting, setting, aligning, may hold another secret entirely. The pattern of work might be the pyramid's hidden code, a choreography preserved in stone, and that pattern, the impossible sequence of motion and precision, is where the next descent begins. Every great design hides a rhythm. The Great Pyramid's rhythm is motion, stones lifted, set, and aligned in a choreography that seems to exceed the limits of human time. Archaeologists can trace the sequence with near-military precision. First came the quarrying, limestone cut at Giza itself, granite hewn from Aswan 900 kilometers to the south. Geological cores match the stones to their origins, with chemical fingerprints so exact that a single block can be traced to a specific bench of quarry. Then came transport. Papyri from Mera's diary confirm flotillas of barges travelling the Nile. During the annual flood, the water level rising high enough to reach channels dug toward the plateau. Engineers from the University of Liverpool reconstructed those canals and proved that, for 3 months each year, heavy cargo could float almost to the pyramid's base. That part of the sequence works. But from water to height, the math turns fragile. The monument contains about 2.3 million blocks. Dividing that number by the 23 years of Khufu's reign yields an average of 1 block placed every 2 minutes, day and night, without interruption. Even assuming 10,000 labourers, the rate borders on mechanical. Excavations at Height El Garab show barracks for rotating crews and ration lists, large enough to feed a small city. The human scale is verified, the tempo is not. Jean-Pierre Houdin's internal ramp model attempts to reconcile the numbers. In his simulation, builders raised the lower third of the pyramid by external ramps, then switched to a spiral ramp contained within the outer shell. The internal galleries, later sealed, explain the absence of debris that an external ramp would have left. Finite element analyses support the idea's structural plausibility, but the evidence remains indirect. Muon scans have not yet confirmed the hidden corridors. The sequence, if true, would unfold like a spiral heartbeat, block following block upward in perpetual motion. Other engineers prefer simpler models, a straight, massive ramp built from local rubble, extended and shortened as height increased. The drawback is volume. To reach the top, such a ramp would require more material than the pyramid itself. No trace that size exists. The most recent compromise envisions multiple small ramps converging, their remains dismantled and reused. Every hypothesis describes coordination on an industrial scale, centuries before the concept existed. Experimental archaeology provides glimpses of method. At the Hatnub quarry, workers recreated the transport of a 2-ton block up an inclined causeway using sledges and water-lubricated sand. The experiment worked. With 50 people, the stone advanced steadily, yet the pyramid's largest blocks weigh 40 times as much. Scaling that success demands forces that multiply faster than population. Calculations by structural engineer Davidovitz show that hauling an 80-ton beam up even a gentle slope would crush wooden rollers and strain ropes beyond tensile limits. Solutions multiply: counterweights, pulleys, or dampened sand ramps, each elegant in theory, each unproven in practice. Inside the monument, sequence becomes even more baffling. The ascending corridor, the grand gallery, and the king's chamber must have been completed while access remained open. Once the granite plugs slid into place, sealing the lower passage, escape would have been impossible unless builders exited through the unfinished upper voids. That implies a precise order of closure, a reverse choreography ensuring that no craftsman was entombed by his own perfection. Computer simulations chart the likely progression: lower galleries first, relieving chambers last, casing stones applied only after interior completion. The plan reads like a single unbroken sentence, written without erasure. When engineers attempt to replicate the schedule digitally, they confront contradictions. Stone supply and placement can be balanced, human endurance cannot. The labor force would have needed shifts perfectly synchronized with transport tides, flood levels, and lunar cycles used to plan navigation. Some historians suspect a dual calendar, solar for ritual, lunar for logistics, coordinating thousands like gears within a clock. No inscription confirms such an administrative feat, yet the consistency of block size suggests standardization, unknown elsewhere in antiquity. Every stone fits the pattern, as if prefabricated for a puzzle that only one generation could solve. Time itself behaves strangely within this rhythm. Construction debris at the base shows phases of pause and resumption. Radiocarbon samples from lower layers differ by decades from those above. The data imply that work may have spanned multiple reigns, perhaps begun under Sneferu and finished under Khufu or Jedefre. If so, the reign of Khufu becomes shorthand for an inherited vision, not a personal project. Egypt's own chronology again trembles. To visualize the full sequence, modern teams use drones and 3D modeling. The pattern that emerges is hypnotic. Stones rising in concentric spirals, cranes of rope and wood lifting blocks in countermotion, light shifting across slopes in daily rhythm, each layer slightly smaller than the one beneath, each angle recalculated by hand. It is not the mystery of impossibility that overwhelms, but the discipline of repetition, the thought that the same gesture repeated 2 million times could build eternity. Still, certain details defy plausibility. The joints of the casing stones fit within fractions of a millimeter, smoother than machined marble. When two stones this size are placed by lever and sand, their faces should chip. They do not. Engineers at the Tokyo Institute of Technology suggest micro-adjustment through wooden wedges soaked and dried to expand and contract, tightening gaps. No evidence proves the method, but it explains the perfection without miracles. The rhythm again returns to patience rather than power. The sequence's final act, polishing, remains speculative. Historical records describe workers using rubbing stones and abrasive paste of fine sand and gypsum. Under microscopy, the surviving casing blocks show directional scratches consistent with such polishing. To finish an entire face would have taken years. transforming the last stage of labor into meditation. When complete, the monument shone like frozen sunrise. That was the moment the rhythm stopped. To the ancient builders, ending the sequence was not finality, but transformation. Ritual texts describe the opening of the mouth, a ceremony animating statues and tombs. The pyramid may have received a similar rite, its apex capped with electrum to reflect the first dawn after completion. In that instant, engineering became theology. The rhythm of stone met the rhythm of the sun. Modern researchers simulate the process to understand the outcome. Every calculation returns the same paradox: physically achievable, statistically improbable. The pyramid should exist only as theory, yet it stands. Each block still rests where anonymous hands set it 4,000 years ago, proof that the impossible sequence was once real. Perhaps that is what disturbs scientists most, the sense that perfection requires not mystery, but relentless method, that human organization can mimic divinity. The monument's magic lies not in how it transcends physics, but in how it obeys them too precisely. And somewhere within that obedience hides another layer, the techniques never written down, the sounds and signals used to synchronize thousands in unison. The ancient instruments have been found. Their choreography remains invisible. To uncover it, researchers now turn to acoustics, magnetism, and the physics of resonance, traces of an intelligence that speaks without words. That investigation begins in the next descent, where silence itself becomes technology. Some technologies make no sound until they're gone. At Giza, the silence is an absence. It's design. Inside the king's chamber, sound behaves strangely. The granite walls do not echo as you might expect. They resonate. Engineers who have tested frequencies within the room describe a narrow band of amplification between 90 and 120 Hz, where sound lingers longer than physics predicts. A clap or chant in that range creates standing waves, vibrations that hover in place. The shape of the room amplifies these effects. A narrow rectangle with flat ceilings, vertical seams, and slabs of pink Aswan granite, high in quartz content. That's the first verifiable layer. Quartz, when compressed, emits an electric charge, a property called piezoelectricity. In small devices, it powers watches and microphones. In the king's chamber, the quartz concentration alone isn't enough to produce usable current, but the resonance it sustains, the way frequencies seem to hang in air, has drawn scientific and speculative attention alike. In 1995, sound engineer Tom Danley tested the chamber using tone bursts and high-sensitivity microphones. His team discovered specific mode coupling, where certain frequencies reinforce each other geometrically. The chamber acts less like a concert hall and more like an instrument, one tuned not for volume but for precision. Nothing in the chamber's inscriptions explains this property. Officially, it's an acoustic coincidence. Yet ancient texts don't ignore sound. The pyramid texts describe utterances that open gates, hymns that navigate the sky. One passage reads, "His voice splits the iron, his words awaken the steps." Most Egyptologists read this as ritual metaphor, but a few researchers have wondered if the builders understood sound not only as symbol, but as tool. Resonance isn't confined to the king's chamber. In the Grand Gallery, the steep corbelled ceiling and polished stone walls produce natural amplification. When teams work there, even footsteps strike like thunder. Instruments used in laser scanning sometimes fail due to internal vibrations. Whether intentional or not, the effect is felt, and it suggests a question. If such acoustics emerged by accident, why do they appear in the chamber at the pyramid's heart? Some propose the structure may have served as a resonance body, like a soundboard in a cello. The blocks of granite, placed in 5 relieving layers above the king's chamber, may have dampened vertical pressure while also enhancing vibrational conductivity. When struck, the slabs produce deep, bell-like tones. There's no record of them being played, but their sonic properties are measurable. In 2018, acoustic physicists from Cairo University ran simulations of vibrational transfer through the stone mass. Their models suggested that small impacts in the gallery could send faint pulses throughout the pyramid. The conclusion was cautious. The structure exhibits passive resonant behavior. Speculation grew from there. Some theorists argue the pyramid may have been tuned to the Earth's natural frequencies, particularly the Schumann resonance, a spectrum of global electromagnetic waves averaging around 7.83 Hz. That frequency, however, is far below what any audible chamber could sustain. Critics point out that the pyramid is not electrically grounded, nor shaped to function as a resonator in this range. Still, the coincidence intrigues those who see the monument as more than tomb. Others explore magnetism. In 1988, a Japanese team conducting magnetic surveys around the base recorded anomalies, areas where the compass needle drifted slightly off true north. Most of these deviations occur near structural corners, especially on the northeastern base. No buried metal was found. Explanations range from variations in subsurface mineral content to alignment with geomagnetic flux lines. The anomalies are small, under 1 degree, but consistent. For those searching patterns, even a fraction matters. And there are patterns. The pyramid's placement corresponds with latitude 29.9792 degrees north, almost identical to the speed of light in a vacuum, 299,792,458 meters per second. Historians dismiss the alignment as coincidence. After all, the metric system did not exist in the Bronze Age. But for some researchers, the number feels like a signal, not because the builders encoded photons, but because the monument keeps inviting numerical meaning. Its proportions, height to base, perimeter to diameter, mirror constants of geometry, pi, the golden ratio, planetary curves. Whether intentional or not, the structure seems to speak in mathematics as much as mass. That duality, sound and silence, geometry and gravity, has led some physicists to call the pyramid an information object. Not a machine, not a generator, but a model of resonance, of balance, of directional force. Such theories remain unproven, often speculative, but they attempt to account for the structure's layered coherence. From base to tip, it behaves not like chaos calcified, but like intention encoded in stone. Ritual text describes ceremonies using sistra metallic rattles that generated rhythmic shaking. Priests may have used sound not just to please gods, but to organize crowds, signal phases of labor, or focus concentration. The pyramid itself may have been built under sound, a metronome of voices guiding motion. That concept finds modern echoes. Archaeologists simulating labor teams discovered that synchronized chanting improves hauling efficiency, lowering oxygen consumption. Rhythm in this sense becomes a tool as vital as rope. The pyramid keeps its own rhythm. Internal airflows, barely perceptible, move in harmonic pulses. When atmospheric pressure drops outside, the grand gallery draws air inward like a pipe. Sensitive microphones detect faint infrasound, too low to hear, but strong enough to feel as vibration. Studies on infrasound exposure suggest it can affect emotion, even perception. Again, no ancient text explains this. But inside the pyramid, silence becomes immersive, less the absence of sound, more its compression into something heavier than air. None of these properties imply the pyramid was a machine, but they suggest it may have hosted a different kind of performance, one where architecture shapes sensation. Acoustic archaeologists now study temples with similar dimensions: Karnak, Dendera, Edfu. Many share proportional ratios with known resonant spaces. The pattern may be more than style, it may be the survival of a sonic grammar. At Giza, no instrument remains to measure it. No inscriptions describe tuning, but the granite still sings, under touch, under tone, what it once resonated for. Ritual, rhythm, revelation remains unknown. And not all resonance travels as sound, because within the pyramid lie channels that never carried breath or light, narrow shafts, too small for people, too precise for error. once thought to be air vents. They now align with stars and measurements beyond convenience. They form a language of alignment and motion, one that the next chapter begins to decode. Some of the most perplexing structures in the Great Pyramid are barely the width of a human hand. They do not lead to the outside world, nor do they offer escape. They rise in silence toward the stars. 4 narrow shafts originate within the pyramid, 2 from the king's chamber, 2 from the queen's. The northern and southern shafts from the king's chamber exit to the exterior at sharp angles, piercing through blocks of limestone and granite alike. Each measures roughly 20 by 20 centimeters and ascends at a fixed incline. In 1964, Virginia Trimble and Alexander Badawi proposed that these shafts aligned with Orion's belt and Sirius, the sacred stars of Egyptian rebirth. Later surveys confirmed it. The southern shaft from the king's chamber points almost exactly toward Alnitak, Orion's easternmost star, as it appeared around 2500 BCE. The northern shaft targets Thuban, the north star of the Old Kingdom. These are not random vents, they are directional signatures. But the shafts from the Queen's chamber tell a different story. Unlike those of the King's chamber, these shafts do not reach the pyramid's exterior. For centuries, they were thought to be mere indentations or symbolic passages. Then, in 1993, German engineer Rudolf Gantenbrink sent a small robotic crawler named Upuat-2 into the southern shaft. After ascending 65 meters, the camera halted before a stone door, a limestone slab fitted with 2 copper handles or pins. The stone was polished smooth, unlike the surrounding rough-cut channel. No light passed beyond it. The shaft did not vent, it concluded. The discovery rippled through Egyptology. What was the purpose of a door that led nowhere, sealed inside stone? Theories proliferated. Perhaps it was a symbolic portal for the pharaoh's soul, a celestial ladder closed to the living. Or perhaps it guarded something deeper. Gantenbrink's proposal to explore further was denied at the time, and the shaft remained untouched for nearly a decade. In 2002, a National Geographic team deployed a new robot, Pyramid Rover, to drill a small hole in the slab. Behind it lay another cavity and another stone barrier. This second door had no copper fittings. The shaft seemed to contain chambers within chambers, a nested enigma built for no human eyes. The northern shaft proved even more difficult. Its entrance from the Queen's chamber had collapsed, and its path bent sharply too tight for straight exploration. In 2011, a flexible snake camera managed to navigate part of the tunnel, revealing similar construction, smooth walls, consistent angles, but no end in sight. The full path remains partially unexplored. Unlike the shafts from the King's chamber, these inner corridors hide their final destinations. What purpose could such effort serve? If the builders required air ventilation, only one shaft per chamber would suffice. These are matched pairs, symmetrical, inclined, and narrow. No text from the pyramid spells out their function, but the pyramid texts contain repeated invocations of ascending the sky, joining Orion, and rising through the door of the horizon. Some scholars interpret the shafts as ritual launch paths, channels through which the king's car, or vital essence, could return to the stars from which it descended. Others view them as spirit tubes, static markers of alignment, not transit. Either way, their accuracy is unnerving. The angles of the king's chamber shafts were not improvised. The southern shaft's incline, 45 degrees, matches the altitude of Orion's belt at culmination. The northern shaft rises at roughly 32 degrees, aimed toward Thuban's meridian crossing. To achieve such targeting, builders would have needed long-term astronomical observation and calculation, possibly using horizon markers or water clocks. The knowledge is real, the intent debated. More radical theories suggest the shafts once carried, not spirit, but signal. Physicist Emilio Spedicato speculated. They may have been waveguides channels for acoustic or electromagnetic resonance. tuned to frequencies amplified by the pyramid's structure. No measurable energy has been detected, but the idea continues to attract fringe speculation. Critics note the absence of conductive material, the static angles, the lack of terminal receivers. Yet the symmetry still puzzles. Why mirror such precision if the shafts served no practical role? And why seal the Queen's chamber shafts completely while leaving the King's open? Some propose the Queen's chamber was once the pyramid's original burial chamber, later abandoned for the higher room. The ceiling would then mark a ritual shift, passageways once open to stars, now closed in ceremonial silence. Others reverse the logic. The Queen's chamber was always symbolic, a cosmic birth chamber for the soul, and its shafts, while blocked, form a spiritual passage. Either way, the labour involved in cutting, polishing and angling these shafts through tons of stone argues for deep intent. In 2019, the Scan Pyramids project used muon tomography to examine the internal layout around the shafts. They confirmed anomalies, small density fluctuations near the endpoints, suggesting that voids may lie beyond the doors. But resolution remains too coarse for certainty. The barriers stand. The mystery remains untouched. For now, the shafts function like memory itself, present, real, but inaccessible. They form the pyramid's most delicate architecture, corridors too narrow for the body, too precise for chance. They reveal a builder's mind, attuned to direction, to cosmos, to legacy, and their very inaccessibility protects their meaning. From above, the shafts map a geometry of return. From below, they feel like sealed questions. What lies beyond those copper-pinned slabs? Another chamber? An offering? A symbolic block? Every possibility remains unconfirmed, but within that uncertainty, awe persists. The pyramid continues to breathe without lungs, to look without eyes, to climb without motion. The shafts are its gaze, and one of them, sealed, silent, angled toward Orion, leads not to a name, but to absence. Because just behind those stones lies a space never opened, a space no text describes, a space without a name. Some spaces are defined not by walls, but by the silence they impose. Above the grand gallery, hidden beyond reach, lies a chamber that no text records and no explorer has entered. It exists because of shadow. In 2017, the Scan Pyramids team, an international group of physicists and engineers, announced the discovery of a large void inside the Great Pyramid. Using muon tomography, a technique that detects cosmic particles penetrating stone, they mapped density variations within the structure. The void measured at least 30 meters in length, with a cross-section similar to the Grand Gallery. It lay above that gallery, aligned along the same axis, but offset by several meters. The announcement sent shockwaves through both archaeology and theoretical science. This wasn't a narrow passage or minor cavity. It was a space on the scale of the pyramid's most significant internal features, and yet it had gone undetected for over 4,500 years. Muon imaging does not produce photographs. It reveals areas of less density, traced by particles that slip through solid mass. The team confirmed the anomaly using 3 independent detectors placed at different positions, inside the Queen's chamber, within a nearby corridor, and outside the pyramid's base. In all cases, the void appeared in the same location, with consistent dimensions. It was not a glitch. Something was there. The void became known in public media as the Big Void, but unlike the King's or Queen's chambers, it bore no title in ancient texts. No labels, no legends, no indications of purpose. It was as though a room had been built, not to be used, but to remain unknown. Initial interpretations were cautious. Egypt's Ministry of Antiquities suggested it might be a relic of construction, a gap left to relieve pressure, similar to the 5 stacked granite slabs above the King's chamber. Yet its sheer length challenged that explanation. Why build a void 30 meters long when smaller cavities had already proven sufficient to protect structural integrity? Others proposed that it may have been part of the building process, an interior space used for hoisting blocks or as a ramp corridor. Jean-Pierre Houdin's internal spiral ramp theory gained renewed attention. If true, the void could represent an unsealed section of that helical tunnel, but its isolation, symmetry, and apparent closure cast doubt. No connecting passages have been detected, only the open space itself. More speculative theories flourished. Some imagined a sealed burial vault, untouched since antiquity. Others pointed to the pyramid texts that speak of the hidden room of the sky, or the sealed place where Ra renews himself. Could this void be a physical echo of those metaphysical ideas? A chamber meant not to contain, but to represent. In the silence of stone, interpretation widened. A second muon scan in 2019, conducted using new ultralight detectors, confirmed the void's presence. More importantly, it refined the estimate of its height, at least 2 meters, perhaps more. It was not a thin crevice. It had volume, enough for a human to stand inside, enough for a sarcophagus, or nothing at all. That's what haunts the imagination. The void might be empty, or it might be full, in ways we don't understand. The king's chamber is monumental, the queen's chamber silent, the subterranean chamber rough, unfinished, forgotten. Each known space in the pyramid serves a purpose that scholars over centuries have debated, yet all three were eventually discovered, entered, and catalogued. The unnamed chamber is different. It has not been reached. No robot has seen its walls. No probe has touched its floor. What is the function of a space that remains forever inaccessible? Some physicists speculate it may serve as a harmonic counterweight, a cavity tuned to the frequencies of the king's chamber, aiding in resonance stabilization. Others dismiss such ideas as fringe speculation. And yet the fact remains, the void is real and it aligns perfectly with a major axis of the monument. Others draw attention to its placement in symbolic terms. In Egyptian mythology, the space above the corridor of ascension was the realm of Ra's renewal, where the soul of the king joined the undying stars. The grand gallery itself was a corridor, unlike any other, steep, corbelled, ceremonial in design. To place a chamber above it, precisely in the vertical heart of the pyramid, is not structurally necessary. It is, perhaps, symbolic, a sanctuary of absence. Architectural analysis has found no evidence of entryways leading to the void. No connecting shaft, no hidden corridor. It is not a room to be visited, it is a room to remain. In this, it resembles a concept more than a container, a null point around which meaning rotates. The Scan Pyramids team has requested permission to drill a small borehole to insert a fiber optic camera, as was done with the Queen's chamber shaft, but permission has not been granted. The void remains untouched. Political caution, conservation ethics, and theological respect intersect at its edge, which makes the mystery stronger. Perhaps the builders intended it this way, not as a secret to be solved, but as a silence to be preserved, a chamber unnamed, because its function was never to be named, and so it waits, above the grand gallery, beyond the reach of light. Its very presence reorders the pyramid's map. No longer a structure of 3 chambers, but 4. No longer a known diagram, but an evolving enigma. The Great Pyramid contains space we did not expect, and perhaps others we have yet to detect. What else lies within the stone? If such a vast cavity could go unseen, what about what lies beneath? The next descent begins not in air, but underfoot, beneath the base, beneath the bedrock, where tunnels bend away from the pyramid's public geometry and toward the oldest questions of all. You walk the plateau of Giza Plateau and notice that every great stone sits atop bedrock, but beneath your feet, the ground still thinks it is part of the grave. For decades, Archaeologists accepted that the three main pyramids were independent monuments built atop a stable base of limestone. That foundation is real and proved. The plateau was leveled, bedrock steps cut, channels carved, and yet recent investigations suggest the visible structure may hide what lies below. For many years, the only chamber under the pyramid was the unfinished subterranean chamber, cut directly from the bedrock and accessed through the descending passage. Modern surveys confirm that this chamber, roughly 27 meters below the base level, shows clear quarry trenches and a portion left in rough form. The known structure ends there, so the bedrock beneath was considered inert, undisturbed geology. But new radar and resistivity studies suggest anomalies beneath the plateau. Sudden voids, L-shaped hollows, vertical shafts too deep for simple quarrying. A Japanese-Egyptian team using electrical resistivity tomography found an L-shaped anomaly beneath the Western Cemetery area, some 3.5–10 milos deep, with sharp edges that raise questions of artificiality. Elsewhere, Italian and Scottish researchers claim to have discovered 8 vertical cylindrical structures extending more than 200 foot beneath the pyramids, spaced in rows, possibly connected by spiral paths. These claims are still fringe, they're not yet peer-reviewed, and have drawn strong criticism from established Egyptology. The independent fact-checking group AFP found them unfounded. Even so, the idea remains. Perhaps more was buried beneath Giza than the visible architecture reveals. Imagine what that implies. An earlier cut of bedrock repurposed as foundation, a network of shafts feeding deep reservoirs or ritual chambers, or a preparatory quarry built for forms now lost. The bedrock steps themselves may have been the first phase of a project, not just ground to build on. Archaeologists observe cut holes and post holes in the rock platform around the pyramid's perimeter that may have served alignment or ritual functions before the main build. The foundations of the pyramid may thus rest not only on stone, but on sequence, and sequence implies phases. What came before may matter as much as what came after. If the plateau held earlier structures, those lower features might have been abandoned, buried, or incorporated. Layers of sand, rubble fill, and archaeology obscure them. One interpretive model suggests the builders used part of the quarrying face as foundation, then filled trenches, placed the pyramid, and sealed the record. Underneath lies the previous incarnation of the site, a planning grid, a temple, or bounds of the sacred. The sand preserved the marks, the stones moved above them. Another theory. The bedrock beneath the pyramid may conceal ancillary structures such as drains, ritual pits, or even symbolic boxes mirroring the chambers above. The fact that the subterranean chamber sits out below unanswered questions suggests the Egyptians did not simply dig for functional space. They dug to transform. The unfinished state may itself be meaningful. A chamber never completed, perhaps symbolizing an underworld state or way station between life and death. For scientists, the promise of deeper tunnels is also a calibration challenge. Ground-penetrating radar and resistivity imaging must negotiate the alongside noise of countless drill holes, modern metal reinforcing, and previous excavations. The 2025 claims of megastructures beneath Giza depend on synthetic aperture radar (SAR) data converted into visualizations, but radar specialists note that high noise, depth attenuation, and geological anomalies can mimic chambers. The Rome team themselves cautioned that their findings require verification. Still, even if we accept that one or two unexplained voids lie beneath the plateau, the implication remains. Our map of Giza is incomplete. The bedrock becomes both base and blank slate. What was buried underneath might not have been tombs or treasure, but systems, drainage, alignment grids, symbolic geometry, earlier works later sealed. The builders may have built downwards before building upwards, and that possibility shifts the story. The pyramid then becomes not just a monument of labor, but of pre-planning, not just a tomb, but a capstone over a bedrock of intention. The fact that explorers still dig into the base of the plateau, still detect anomalies, suggests the pyramid might be a module, placed on an underlying machine we cannot yet see. You walk around the pyramid's base, and note how the casing has been stripped from the east face, but the bedrock beneath remains carved into steps. Why would quarrying stop so suddenly? Why would the builders deliberate on bedrock so carefully? Because what lies beneath needed to be anchored first. The deeper you dig, both literally and metaphorically, the harder it becomes to separate construction from ritual, foundation from myth. If the ground under the pyramid houses tools, chambers, or alignments now invisible, then the monument is not simply built by humans. It is rooted in something older, and that something older challenges time itself. If earlier phases exist, and they may still rest unentered beneath the sand, then the chronology we hold may shift. What if the base belongs to one generation, the core to another, and the apex to yet another? The pyramid may not start and finish in the reign of Khufu, but lie across multiple ages. That thought unsettles precise timelines and invites historians back into the quarry. As you stand at the threshold of the mortuary temple, you feel the plateau beneath your feet rise at the edge, tilted subtly toward the Nile. You realize the pyramid's real support may be invisible. What the world sees is simply the final act of a much longer performance, one that began below the surface, in the silent bedrock and hidden trenches. In the next chapter, we will descend into the consequences of that deeper mystery, the impact it has on chronology, on ritual functions, and on our understanding of the pyramid, not just as stone, but as story. You have followed the geometry, touched the tools, measured the voids, and now you begin to see how the rules that once seemed certain begin to flex. Historians bend them, engineers test them, the stones of the Great Pyramid of Giza bend them still. In textbooks, a pyramid is defined by its builder, its date, its purpose. Khufu, 2580-2560 BCE, tomb of a king. Yet every new measurement nudges these categories. The alignments designed to fix north drift when you consider Earth's precession. The radiocarbon dates shift when recycled charcoal is included. One fact stays firm: the structure obeys laws of geometry and gravity that humans still replicate today. But the rules governing interpretation, that the pyramid is simply a tomb, simply a monument, simply a part of the old kingdom, those rules begin to crack. Structural engineers model the pyramid under load. 2.3 million blocks stacked, each following the weight distribution paths inferred from the relieving chambers. The rules of physics apply. Yet when you map the internal void discovered in 2017, at least 30 meters long, unseen for millennia, you force the structure into a new category. It obeys load, yet hides nothing obvious. That anomaly forces them to bend the rule. All internal spaces were known. The answer becomes, maybe not. Archaeologists, too, face the bending of rules. The expectation was that royal inscriptions, construction records, and funerary goods would define the context, but what they found instead were workers' villages, ration lists, quarry diaries, and silence at the heart of the tomb. The tools confirm labor, the capstone is missing, the word burial only appears in later texts. The rule that the pyramid was built to entomb a pharaoh becomes one possible reading, not certain. Then there is the rule of linear sequence: draft, build, finish. The pyramid obeys that superficially, but layers of quarrying, phases of casing, sons succeeding fathers, all hint at a process elastic in time. The rule that a king built the pyramid within his reign begins to bend under decades of radiocarbon, astronomy, and structural modeling. Even mythological rules bend. The pyramid texts speak of the king ascending the imperishable stars, of doors of fire and rope of metal. Scholars once reserved myth for metaphors. Now the shaft alignments, the resonance phenomena, The voids make those metaphors feel like footnotes. The rule myth mechanism loses conviction. As you walk the desert at dusk, you realize the pyramid isn't just built to conform, it is built to challenge. It conforms to gravity, yet resists full understanding. It meets astronomy, yet smiles at chronology. It shows tools, yet hides the whole sequence. Engineers who built the large voids muon detector arrays speak in hushed voices about error margins and signal anomalies. Everything fits, one said, and nothing makes sense. For scientists used to equations that resolve neatly, the pyramid offers resonance, but not resolution. When the detector maps the void, the data obey cosmic ray physics perfectly, but its meaning belongs to architecture and human intention, and that doorway bends the rule that all rooms serve obvious purpose. At the site, guards still forbid drilling beneath the pyramid. The rule of intrusion. If you cannot justify conservation, you cannot remove stone. Yet the promise of discovery tempts bending that rule, as robots inch into shafts, as drones hover above voids, as universities call for new scans. The pyramid forces the question, when does preservation become obstruction? Historians sometimes use the term half-curious. They propose scenario after scenario, pre-dynastic foundations, foreign labor, cosmic coded geometry. Most proposals collapse under scrutiny. Yet the pyramid keeps inviting them. The rule that only rigorous data matters bends under human eyes that hold the line between fact and wonder. It's a bending of rules not to destroy them, but to reveal their elasticity. What does that mean for you, standing at the western edge of the plateau, the last light catching the quartz in the casing stone remnant? It means you're viewing architecture that knows more rules than your discipline expects. It means you're witnessing something built under rules and yet beyond them. So you ask, if the pyramid bends the rules of construction, chronology, purpose, and ritual, then what remains unbent? Perhaps only one principle, that it demands acknowledgement. The triangle of stone becomes transcendent, not by breaking physics, but by bending expectations of human capability. That bending is what terrifies scientists, to realize their rules may yield, while the stone does not. And if rules bend, what then? If chronology shifts, if purpose expands, if alignments redefine the sky, then our map of the ancient world is not wrong, it's incomplete. The boundaries between monument and machine, art and architecture, ritual and engineering blur. You light a torch, or a virtual torch in your mind, and descend once more into the void of unanswered questions. The rules bend, but the stone endures. That endurance is both invitation and admonishment, because beyond the bend lies the break. A break in the narrative that hasn't yet been accepted. And that break is where you'll look next. As dusk falls over the plateau, the stones of the pyramid begin to vanish into the desert's shadows, and you realize they were never meant simply to stand in sunlight. They were built to play with it, trap it, release it. At the height of its glory, the outer casing of the monument shone like polished alabaster under the Egyptian sun. Archaeologists confirm that the White Tura limestone blocks, still found sparsely at the base, reflected upwards of 80% of the light that struck them. Surface samples show embedded mica and quartz inclusions that, when cut and polished, scatter rays almost uniformly. Modern surveys of the surviving casing fragments document microstriations aligned toward the apex, as though each block had been oriented to catch and reflect. Within that outer flash, the interior shifted into darkness, and light acted differently. In the vast grand gallery, the ceiling soars upward in a trapezoidal chamber, finely polished and sealed. Visitors walking its polished floor note that even a soft footstep produces resonance. Measurement shows frequencies lingering near 90–120 Hz in the king's chamber, others registering longer fall times than engineering models would allow. These acoustic behaviors are confirmed by independent recordings, reflections that hang in the air, vibrations that extend beyond what simple limestone geometry predicts. Why? Scholars disagree. Some propose that the internal geometry and material composition were chosen to exploit piezoelectric effects. The granite blocks of the king's chamber contain enough quartz that under vibration they produce minute electric potentials, confirmed in laboratory sampling of removed fragments. Others caution that these effects are too small to power anything. The evidence suggests design, not power generation. Either way, the mixture of sound, stone, and reflection gives the interior a feeling of presence, not just of tomb, but of system. Outside again, the shadows drag along the eastern slope, and the casing stones catch the last red of sunset. The pyramid transforms into a beacon as its sides radiate light backward into the desert, proof that this was not a monument built to hide, but to display. The builders measured the horizon, not just the tomb chamber. They tuned proportions not only to depth, but to visibility. Every observation confirms that the structure engaged with its environment, chemistry, stone composition, acoustics, chamber resonance, geometry, angles, alignments, optics, reflectivity, and even magnetics, all fields of study that modern science has only recently begun to explore. Some of the most recent papers model the pyramid as a resonant cavity for electromagnetic waves. Simulations show that under specific frequencies, wavelengths of 200-600 meters, the monument could focus energy into internal spaces and beneath the base. Engineers at St. Petersburg's Itomo University published results suggesting that the pyramid acts like a dipole or quadrupole antenna under resonant conditions, concentrating radio waves inside its structure. Although no usable power has ever been extracted, the fact that the effect can be modeled raises the question: did the builders understand resonance beyond stone? Yet skepticism remains prudent. Many scholars warn that coincidence does not mean intention. Measuring reflectivity of casing stones does not confirm ritual purpose. Documenting resonance does not prove it was used. What the pyramid resists is simple explanation. If the numbers are verifiable, the meaning remains elusive. What troubles scientists most is this: the pyramid engages with multiple physical domains, optical, acoustic, electromagnetic, and does so with precision. That precision invites the question: if built purely as a tomb, why apply such broad mastery? If built as an instrument, where is the instrument's use? And if built as both, why no ancient document describes the system? Surrounded by stone, the answers still echo faintly. You step into the descending passage at twilight and catch a sliver of horizon light through the original entrance. The shaft throws a triangle of orange on the ancient floor. That light tracks with the calendar. One day each year, it reaches a specific point. The pyramid's geometry has brought the sun inside. Similarly, the narrow shafts that rise from the Queen's chamber, sealed with copper-fitted slabs, align with stars, channels of light or spirit, perhaps both. The interplay of shadows and light becomes metaphor, but remains physical. The pyramid was built to last, not only because stone endures, but because optimization lies in balance, dark and bright, resonance and stillness, stone and void. Researchers mapping the interior voids discovered by muon tomography find that the big void above the grand gallery lies along the central axis, in shadow from direct light, but aligned with the body of the monument. Its purpose may be structural, but its placement adds optical and acoustic implications too. As the evening cools, you notice the stones themselves shrink silently. The thermal contraction cracks fine lines in the casing remnant, showing how the monument responds to light, heat, and time. The builders designed for that too, though how they calculated it remains unknown. Engineers studying shrink-swelling cycles confirm that the estimated expansion of the blocks under sun is about 5 millimeters, a difference enough to misalign joints if not accounted for. The fact that the joints still fit so tightly after millennia suggests they did account for it. And so you walk around the base, past the granite blocks from Aswan, weighing 25 to 80 tons. their faces polished to better than modern machine finish. You reflect on how each facet of stone seems prepared, not for burial, but for interaction with material, with environment, with observer. The design is inclusive of your gaze, your measurement, your question. In that inclusion lies the terror for scientists, the possibility that the monument was built to be scrutinized. And if it was built for scrutiny, then every tool, every survey, every laser scan becomes part of the system, not just researchers probing passive stone. The pyramid may track our knowledge as much as we track its data. Night falls completely, and the plateau grows cold. The stones lose their illumination and become silhouette. The pyramid becomes pure geometry against the sky. The unopened chambers, the sealed shafts, the hidden voids still unentered. It stands like a question without punctuation. You recall the claim that the latitude of the site, 29.97922, mirrors the speed of light in meters per second, 209,792, 458 meters s. Many dismiss it as numerology, but the coincidence persists. Whether symbolic or accidental, it amplifies the sense of scale design. The pyramid doesn't simply fit the earth, it reflects it. The shadow of the site falls across mathematics, physics, and myth. In the stillness, you hear the desert wind rattling the blocks of the causeway, the whisper of water in ancient channels, the faint hum of instruments left unsent. You realize the pyramid still listens, even as we talk, because at the end of the day, after all our scans and surveys, the only light we bring into its chambers is our own inquiry. The pyramid awaits, not just as relic, but as participant. And as you step away, you know that tomorrow you will return for measurement, for simulation, for scanning, and for question. But the pyramid does not wait, it watches. As dusk cloaks the plateau, the stones of the great monument begin to vanish into the desert's long shadows. Yet in that disappearance you realize they were never meant simply to stand in daylight. They were built to play with it, to trap it, to release it. In the full glory of its construction, the outer casing of the monument once shone like polished alabaster beneath the Egyptian sun. Surveys of surviving fragments confirm what travelers long ago witnessed. The white Tura limestone blocks, still embedded in the base, reflect upwards of 80% of the incident sunlight. Microscope analysis reveals grains of quartz and mica embedded in the stone, their facets angled to scatter rays almost uniformly. Modern measurement records microstriations aligned toward the apex of the structure, signs that each block was oriented, perhaps not only structurally, but optically. Within that outer brilliance, the interior shifts into penumbra, and light behaves differently. Inside the Grand Gallery and King's Chamber, sound resonates, shadows deepen, and light becomes a subtle presence. Acoustic measurements in the King's Chamber pick up resonances near 9120 Hz that last longer than simple reflections should allow. These phenomena are verified by independent recordings, vibration echoes that hang in the air, waves travelling longer than expected given the sandstone and granite surfaces. Why does this matter? Because the architecture appears to engage more than mass and angle. It engages sight, sound, sensation. On the outside, the casing stones turn the pyramid into a radiant beacon. On the inside, geometry, mineral content, and dimension combine to create a space where light, shadow, and whisper meet. One moment you stand outside in glare, the next you step inside and sense a shift. It is colder, quieter, as though the stone inhaled the sun and exhaled stillness. Some engineers interpret this as purely structural. For example, the casing's shine might simply reflect a desire to visible dominance, and the interior acoustics could be incidental byproducts of tightly fitted granite. But skeptics note that the combination of optical polish and acoustic resonance appears too consistent across separate chambers to be accidental. One recent simulation treated the pyramid as a resonant optical cavity. Calculations show that under certain frequencies of sunlight and internal sound, the stone could amplify faint pulses. No machine remains, no inscription declares such a function, but the physics aligns. Outside, as the sun falls westward, the eastern face still holds remnants of casing. The quartz flecks, catching the last rays. You observe that the shadow of the pyramid stretches perfectly straight, bisecting the desert in a sharp line. For precisely 12 minutes, the slope casts a dark triangle along the face. Photographers measure the reflection. Poets call it miracle. For a moment, mathematics and myth share the same language. Yet the monument's mastery of light hides a paradox. Its interior was built for darkness. Torches and lanterns leave nearly no soot on pristine surfaces. Wear patterns suggest workers used polished copper mirrors to reflect light deep into the corridors. In recent exploration of the shafts, residual polish on their walls indicates they were once highly reflective. This redirection of light into sealed spaces seems intentional, an act of illumination that required engineering as much as ritual. A beam of sunrise may have once travelled along that shaft, piercing the stone until it hit the granite coffer in the king's chamber, then fading into quiet. If so, the pyramid was not merely a tomb, but a prism of sunlight and shadow. Some scholars go further. They note that quartz, when stressed, emits weak electric potentials, a phenomenon known as piezoelectricity. Granite rich in quartz can under vibration produce minute electrical charges. Although the amounts are infinitesimal and unusable by modern machines, the presence of such material in high load zones of the pyramid is verified. Whether the builders knew of it in chemical or symbolic form is unknown, but the correlation fascinates physicists. For skeptics, the Tower of Coincidence still stands. Yes, there is polish. Yes, there is resonance. Yes, there is alignment. But each might be independent responses to environment, quarry techniques, and religious symbolism. The challenge for scientists is that the data are real, but the interpretation remains elusive. Verified optical and acoustic behavior exists. Meaning is still intangible. You begin to walk the perimeter. The desert wind rattles the causeway stones. The temperature drops sharply. The plain limestone turns grey. The shadow swallows it. At the same time, look just above the casing, where the first row still remains. The surface is now etched, not by quarry, but by heat and time. Under the microscope, you find micro cracks corresponding precisely to thermal expansion and contraction, changes in stone dimension over thousands of years. Engineers estimate that each diurnal cycle caused expansion near 0.5 millimeters in length across meter-scale blocks. Yet the joints remain tight. The builders anticipated time's effect and designed for it. That is a form of technology, silent, embedded in stone. In the evening, you enter one of the corridors. A narrow beam of moonlight creeps through the original entrance and projects onto the floor. That possibility was part of design. The descending passage's angle matches the sun's setting rays for only a few days each year, making the pyramid a calendar, a timekeeper of brass and stone. The light striking the west wall marks a position at dusk. You stand at that mark, you feel the alignment, you realize the pyramid doesn't just sit in the chronology, it participates in it. Scientifically speaking, the implication is this: the pyramid engages with multiple physical domains, optics, acoustics, electromagnetism, each measured with accuracy. What terrifies scientists is not that the pyramid breaks physics, but that it obeys multiple branches so well. A structure built as funereal also behaves as instrument, which raises the question, if built purely as a tomb, why apply such broad mastery? And if built as an instrument, where is the device? You leave the monument under a sky lit by stars you once aligned it to. Orion's belt glows above. The casing stones have lost their brilliance. The interior still hums. The pyramid becomes silhouette, geometry against sky, unanswered. In that stillness the question remains. What happens if you open the crown of the pyramid? If you lift one casing stone and peer inside the voids? Would the resonance change? Would the light shift? Would the mathematics reveal its meaning? The horizon stretches in front of you, the desert winds curl at your feet, and you know that the pyramid watches differently anymore. It is not just wall and mortar, it is question and invitation. Because at the end of the day, after all our scans and our models, the only light we bring into its chambers is our own inquiry, and the pyramid awaits. As you stand once more on the Great Pyramid's plateau, the desert wind carries not just dust, but echoes of labour, alignment, and ambition. The structure beneath your feet has endured longer than empires, recorded more precision than most scientists expect, and still leaves unanswered questions that hum under the stone. We have journeyed from alignment to material, from hidden voids to acoustic resonance. Yet at this penultimate stage, you sense a pattern. The pyramid behaves like an engine built for measurement and memory, not just for memorial. Every camera, every muon detector, every laser scan maps what is visible, but the invisible remains. The final echo is not what we measure, but what we cannot yet measure. Consider this. Engineers calculating the energy required to lift stones argue that only thousands of workers could have managed the load if they worked in parallel. Historians find no evidence for such scale in contemporaneous texts. Astronomers trace alignments backward through precession and find proposals that reach 10,500 BCE, but mainstream chronology rejects them. The timeline flexes when confronted with precision. In the evening light, the pyramid seems still, but you realize it has become a problem rather than a relic. Scientists speak more softly here. They hedge their statements with possible, suggests, could be, because the ground, the geometry, the stone, all of it holds firm. It is the certainty of our understanding that shakes. You walk into the Queen's chamber, that quiet, sealed space, whose shafts rise toward the stars, but block at the threshold. The stone handles, the copper pins, they remain untouched. There is no inscription explaining them, only the work of machining and polish that screams human effort. But who's human, and to what end, remains a question. This hesitation is the echo. Similarly, you stand in the grand gallery and sense the void above, discovered by muon tomography, a chamber too regular to dismiss as accident. Its existence doesn't answer yet, it amplifies the mystery. Why carve a space so large and leave no document? Why align the pyramid so perfectly and leave no manual? The echo is the question itself. Outside, on the exterior casing remnant, you touch quartz-laden stone, smeared with the desert's memory. You notice micro-striations that point upward. The precision is verified, the meaning remains interpretive. You feel the pyramid's hand in your data, your maps, your scans. It watches your attempts to decode it. For researchers, the fear is not that they will solve the mystery, it's that they will prove how much they still don't know. The pyramid doesn't terrorize because of what's inside, it terrifies because of what the human mind doubts it can ever fully know. That doubt manifests in late-night meetings, in rerunning scans, in rereading quarry diaries. Every piece of new evidence expands the perimeter of ignorance. As night deepens, you glance at the plateau's horizon, where the last light kisses the causeway of the smaller pyramids. They descend in size, but look upward in like musical notes on a score. The pyramid's geometry encodes observation, repetition, ritual, and endurance. The final echo is that the builder may not simply have built for today or for death, but for eternity, and eternity means continual return. In that return you find yourself again, crouching beneath the copper-fitted door, inside a shaft, listening to the air. You chart the coordinates, you note the alignments, you touch the granite and list your instruments, and still you wonder if the greatest instrument was the human mind. The parts we measure are stone and steel. The one we cannot measure is will, vision, belief. When ancient priests spoke of the pharaoh ascending, of star fields opening, of dimension folding between sky and stone, they encoded metaphor, yes, but perhaps they encoded method too. The pyramid becomes intersection of faith and survey, of mathematics and music, of earth and cosmos. And at that intersection lies the echo, what is done and what is undone. You step back into the desert, leaving the pyramid framed by stars. You carry measurements, models and hypotheses, but the pyramid carries memory. It remembers quarrying, transport, alignment, placement. It remembers the sound of hammers, the chants of workers, the cold night air on limestone. It remembers what we cannot. If this were the final word, you might close the gate and leave unanswered. But our journey arcs toward the last section, where we ask whether the secrets still buried might one day wake, whether the greatest mystery is yet to appear, and whether science will ever feel settled again beneath this triangle of stone. Take a slow breath, because the next passage may not be about stone, but about silence. And the silence may be louder than any echo. You have circled the pyramid, traced its stones, measured its voids, and now you pause at the gate. The great monument has offered you corridors, alchemy of stone, hidden spaces, and unanswered numbers. But as you prepare to leave, you realize the lock has not been changed. You still hold the key. The key here is not a lever or a lever stone. It is the question that refuses to close. What if the pyramid was never meant to be fully opened? The builders may have designed it less for reaching inside and more for keeping out, and the final key lies in patience, not forced entry. The first part of the key is time. The pyramid has waited longer than most civilizations. You stand on its steps with surveying equipment more powerful than 19th century theodolites, lasers sharper than copper chisels, detectors more sensitive than blunt probes. Yet the structure still defies final explanation. The urge to open every door collapses against the fact that some doors remain sealed and some measures remain beyond replication. The key is the admission of uncertainty. Second is rhythm. You have seen how the blocks, the beams, the shafts align, how sound lingers and light bends, how voids appear where none were expected. All these point not to a singular mystery, but to a system, an infrastructure of intention. The key is to read the monument, not as snapshot, but as process. The pyramid's meaning may lie not in one stone, but in the sequence of placing them, in the methods now invisible, in the ritual now unspoken. Third is silence. Nearly every chamber you visited is empty, unmarked by gold or inscription. The final key is to recognize that silence was part of the design. The sealed door in the Queen's chamber shaft, the hidden void above the grand gallery, the unexcavated trenches beneath the bedrock. These are not failures of archaeology, but choices of ancient builders. The key is knowing that not all architecture is meant to be revealed on our schedule. You pause at the platform where the casing stones once glowed. The last piece of white Tura limestone remains, polished just enough to catch the setting sun. On that surface you trace your finger and feel the cool micrometer-tight joint. Generations of engineers measured tolerances this fine with modern machines. The ancients achieved them with copper, grit, and muscle. That encounter is your threshold. The pyramid is less monument than mirror. The key is to let it reflect your questions, not just your answers. Ahead of you lies the last chamber. Not a room beneath the stone, but the space beyond knowledge. The final key is that this chamber is inside you. Will you leave satisfied or remain curious? Because the pyramid's builders were patient. Their key was installed in ancient mortar. Their scale was epochal, and their intention may have been not monument, but message. You turn back one last time and survey the horizon. The desert is quiet. The pyramid stands in silhouette, 4,000 years old, yet stirring with possibility. The tools of probing beam and muon detector fade in the dusk. The sight of a single casing stone glinting in amber light remains. The key did not unlock an answer. It unlocked the question. Take a slow breath and step forward. You reach the threshold at last, the moment when discovery yields into quiet. In this final chapter you confront not what the pyramid may hold, but what it has always held, possibility. Historians note that the Great Pyramid stands neither simply as tomb nor temple, but as an open question in stone. Evidence shows the monument was built with precision that rivals the modern world, its base leveled to within centimetres, its faces aligned to cardinal directions within minutes of arc. At the same time, no inscription inside explains its mechanics completely. No papyrus diagram survives, no blueprint marks the ramps, no engineer's manual remains. The silence becomes part of the structure. You've traced block by block, shaft by shaft, void by void. You've measured how light glinted off polished casing stones, how sound lingers in the king's chamber, how muon detectors revealed a void above the grand gallery. You've weighed every plausible explanation, from ramps to resonance, from construction cavity to cosmic library, and still something persists unresolved. That persistence is not failure, it is invitation. For the scientists, the most unsettling truth is this: the pyramid was built to last not just for millennia, but for minds prepared to ask questions over eons. What you measure today may settle the angle, but the meaning keeps shifting, and the shift is intentional. Take the latitude of the site, 299792 degrees, which mirrors the speed of light in meters per second. If you drop the units, 299792, that numerical echo has no documented ancient purpose, yet the coincidence remains. It stands not as proof, but as reflection. We look at the pyramid, and it looks back. You remember the workers' city at Heidelgurab, the copper tools, the fleet of barges on the Nile, described in the diary of Mira. These are verified facts: human hands, human effort, human enterprise. What you also remember are the sealed shafts, the unknown voids, the mathematical proportions whispering through stone. The combination unsettles the boundary between craft and mystery. When the rules bend, when chronology slips, when interpretation fractures, the pyramid does not collapse. It models endurance of ambiguity. In those moments, you realize the end is not the solving. The end is the beginning of the next question. Because now you hold what scholars call the final key, the recognition that some architecture is built as question more than answer. It invites not submission, but curiosity. It invites you. So you step back into the desert night, the stars above arranged in patterns, the builders once tracked. Orion is visible, Sirius glimmers, the circumpolar stars revolve, the shafts of the pyramid still point, the geometry still holds, the measured facts remain, and the silence remains. In this quiet you feel the scale of time. Empires fall, tools rust, technologies vanish, but the pyramid endures. It remembers quarry, labour, complication, collapse and restoration. It remembers what we forget, how effort and vision can align with world-scale precision and still yield mystery. You exhale. The wind shifts and lifts sand at your feet. The moon traces a silver path across casing stones that once captured sunlight. For a moment you imagine the pyramid as a lens of history. You imagine yourself as part of the lens. You realize that to study the pyramid is not simply to learn about the past, but to engage with intention, endurance, and human possibility. Historians speak of its legacy, the only surviving wonder of the ancient world, a touchstone for architecture, mathematics, astronomy. Engineers speak of its precision, base accuracy of millimeters, casing blocks fitted to 0.5 millimeters gap. Yet the most enduring testimony may be its capacity to challenge. It challenges what we consider possible, both in ancient time and today. And so this journey ends where it began, facing the same stone, asking the same simple question. What did they build? How did they build it? Why? You might never know the full answer, but you now know the shape of the questions. And sometimes, shape is enough. Take another slow breath, because in that pause between stone and sky lies the true monument, not just built by the Egyptians under Pharaoh Khufu, but built for you to witness, to wonder, to remember.